Hive is a data warehouse infrastructure which is used to process structured data in Hadoop. It resides on top of Hadoop to summarize big data and makes querying and analyzing easy. Understanding this, we have come up with this Hive tutorial. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
So let's talk about Hive, right? Which you people might be mostly interested. And usually I'm not a slides person, but for Hive I need some slides. This has around 60 slides. I will not run in all of them, don't worry. I'll share it with you, you can go through that. I'll run a couple of them to get an idea, right? And so that otherwise everything I have to draw and explain, it will be difficult for Hive, right? So Hive is actually very simple. In 2005, when Hadoop came, most of the major vendors started using Hadoop, like Facebook, Yahoo and all. But they all faced one common problem. The problem was that Yahoo started using Hadoop, but Yahoo had a lot of developers who did not know Java. So the problem was that they had to write MapReduce programs, and skill set was the problem. You can't say that everybody should learn Java and start writing code. So Yahoo found it very troubling. Same time Facebook also started using Hadoop, and they also had the same problem. Facebook had mostly SQL developers, and they were not comfortable with Java. And way back in 2005 and 6, we had only MapReduce. There was nothing else on Hadoop. Okay, plain MapReduce, nothing else. So the Hadoop ecosystem we saw in the last class, none of that was available. So everybody was confused. So Yahoo and Facebook started two projects same time. So Yahoo created something called a pig, the creature pig, animal pig. Seriously, it's called pig. pig.apache.org. See, that's a pig, real pig creature. So Yahoo created this tool called pig. It's a scripting language. I teach a course called a pig on Hadoop, only on pig. It's a very interesting language, scripting language. Advantage is very simple. You learn this language and then you, whatever analysis you want, you write in that language. It's a script. So very small, like 4 or 5 lines max or 10 lines. And once you write your pig script, you say run, it will convert your pig script into MapReduce program. So you don't have to learn MapReduce, you learn pig. And somewhere in 2010 and 11, there was a heavy job inflow for pig developers. 80% of Hadoop job was handled by pig in 2010. 80%. It was such a successful language that everybody was dying for pig. I have taken only pig trainings. People don't, because that was the effect of pig actually, right? Because it's a very easy language, scripting language. You just learn it and everything will happen behind the scenes. You want to do a join operation, you say join A comma B, that's it. Even SQL queries are more complicated in join. You have to say A dot, B dot. Here nothing. Take A, B, join A comma B. Done. Joining done. Simple inner join I'm saying. So people started using pig extensively. But at the same time, Facebook developed Hive. Hive's idea is different. You write SQL. Okay, you create your databases, your tables and all the blah blah blah. You write SQL and Hive will convert your SQL query into MapReduce. Same concept. So two companies developed, one pig and one Hive. They didn't know that they were doing the same thing ultimately. But then what happened, somewhere around 2010-11, pig started losing the attraction because Spark came. So when Spark came and became predominantly useful, Spark is also very short and like a script you can write in Python and all, very easy to write. So Spark and pig are almost similar. So people thought like, if I am learning something very short and interesting and very fast, why should I learn pig? I can learn Spark itself, right? So pig is no longer used by anybody, very rarely. Pig is gone almost. Hive is not gone because it is SQL. SQL will be there till the world exists. Right? No questions asked. right? No questions. SQL is SQL. So you can't get rid of SQL, right? How do you get rid of SQL? What if all the ETL developers and there's a huge community to back SQL, not like pig. I actually like pig more, but there is nobody to back pig, right? There is a lot of people who back SQL, right? And that is not the only reason. Hive is a beautiful data warehouse. It is treated as a data warehouse of Hadoop, meaning you can create tables and you can query the data. So most of the visualization tools and all, can use Hive in the backend to fetch the results and all. So Hive became very popular, and now what is happening? Hive is there, plus Spark is using Hive. In Spark, you have a module called Spark SQL that uses SQL language. Now that guy can process itself. It can also talk to Hive. So whatever data you have in Hive, Spark can also read. So Hive is predominantly used these days, and Hive will always be very popular. It may be, I think, one of the most popular ecosystem tool is Hive so far in the industry, because it's been 10 years, 12 years, and still community is very much. So the command wise it is very simple because it is SQL, and I don't think I have to teach you SQL. That's not the idea behind the session. You will already know SQL. But we will just see what is happening behind the scenes if you write a SQL query, and some of the advanced concepts in Hive like partitioning, bucketing, indexing, these kind of things. And from the industry experience, there is one major thing. There are two major vendors, Hortonworks and Cloudera, right? Now Hortonworks uses original Apache Hadoop. That is their propaganda. So whatever, Hive is also Apache product, it's open source, right? And whatever major changes are there in Hive are predominant in Hortonworks, not in Cloudera. Cloudera is actually not so good at Hive. We are using a Cloudera lab. That's bad actually. I mean, I'm not blaming the lab, but Cloudera is actually a bit bad in Hive side. I'll tell you the reason, because I teach at Hortonworks. That is the reason I'm able to tell. In Hortonworks, they have a project called Tez. Some weird people from Delhi created this project. Tez is a Hindi word. There is a weird movie by that name also, right? Have you heard Tez? Tez. Speed in Hindi. So Tez is a, how do you say, it's not a replacement. Tez is a project created by Indians. Then they gave it to Apache. It became open source. Tez is faster MapReduce. So what these guys did, normally in MapReduce what happens, you read the data, right? And then you do mapping, and then you store the output in hard disk. Again in Shuffle you read the data, do the shuffle, store the output back in hard disk. Again reducer will read from hard disk. So some weird guys thought, why don't we do all this in memory? We don't want to use hard disk, read the data once, do all the map, reduce, shuffle, and then push the result. So your MapReduce becomes 10 times faster. That is Tez. So it's a DAG, a directed acyclic graph concept, and Tez was given to Apache. What Hortonworks does, if you write a Hive query, they will convert it into a Tez job, not MapReduce job. So Hive queries are very faster on Hortonworks. In a Cloudera cluster, Cloudera doesn't support Tez, because Tez is contributed by Hortonworks. They are competitors, right? So if you are working on a Cloudera cluster, you will never see Tez in your life. They won't allow. So the problem is that if I am writing a Hive query on Cloudera, it's very slow, because it will convert to MapReduce, run as a MapReduce program, takes a lot of time. If I am writing the same Hive query on Hortonworks, it's at least 5 times faster, because it converts to Tez job. By default it is Tez, and Tez is superb. You can't compare, right? So that is one drawback. I mean, so when you start working in the industry, so these days mostly people are moving to Hortonworks for majority of reasons, but the stake is at Cloudera only. Number of users are more for Cloudera, but over a period of time probably people will shift to Hortonworks. So these are good to know information. So then you will be thinking that from Cloudera there is no answer to this. No, they have Impala. There is a product called Impala, Apache Impala. Impala's contribution is mostly from Cloudera. Impala does the same thing what Tez does, in memory, fast, real-time queries. So I'll show you Impala. We have Impala in the cloud cluster. I'll show you Hortonworks cluster also if you want. So Tez itself as a project is not really, not really, how do I say, important right now. Since Spark came, most of these things are gone, including Tez. Because Spark is also in memory, Tez is also in memory. So when Spark came, Tez relevance is not there. But the only relevance is that if you are running a Hive query, it converts it into a Tez job, so it's faster actually on Hortonworks platforms. So I will show you a Hortonworks cluster probably tomorrow. Okay, I have an access. I'll show you the Tez job running. You'll see the difference actually. So but there are a lot of companies who run traditional Hive, only Hive. Like they don't want to use Spark, they just want to use Hive. For them, going to a Cloudera may be a bit challenging because Hortonworks by default give you free Tez, right? So Tez is fast. Also, Tez is fault tolerant. Impala is not. I'll discuss probably tomorrow, probably too early to discuss, but there are SQL engines are too many actually in this category, and there is a tight competition between all of them. And it's all marketing gimmick. You go to Cloudera, they will say that Impala is the best in the world. Never listen to Hortonworks. Hortonworks will say that. And Hortonworks recently, Hive recently announced something called LLAP, Apache Hive. LLAP is real-time queries using Hive. Hive is normally batch processing because it is converting into MapReduce, right? But recently Apache announced that Hive can support real-time queries. That's called LLAP. Real abbreviation I don't know. Long live and process. That is not the real one, but we used to say long live and process. It is still in beta, not so. But the problem, LLAP is available only on Hortonworks, no Cloudera. Open source, right? Because it is a contribution of open source Hive, which is available only on Hortonworks. Cloudera cannot get it. So they are still with Impala. Impala is the only solution they have. So when you talk about Hive, there are a lot of things, but you should be aware of the industry, what's happening, right? So these are the reasons why people are shifting towards Hortonworks. Some of the major things I see compared to that doesn't mean Cloudera is bad. Okay, it's not like they are also having great support. Their technical support is excellent, and even with this Impala, they do a lot of tricks actually too. So if you have a problem, they'll give a solution. But a lot of people are preferring this open source initiatives. Hortonworks and all are open source. But the problem is, I told you, right, I was with GE, they use LLAP, none of the queries work most of the time. It is open source, right? If it doesn't work, you can't blame. Cloudera will fix it because it is proprietary, like iPhone and Android, right? So open source, you get a lot of features, but it will work or not work, you cannot guarantee. That's one thing. But they will blame internally on Apache. They say that we'll give you technical support within the limits. So originally the product is by Apache. So Hortonworks cannot fix directly because it's an open source community. Most of the things work. I mean, I'm not saying that everything doesn't work, but open source has its own drawbacks sometimes, right? But I'm seeing a lot of people migrating to Hortonworks actually these days, right? So in Hive, what you need to understand is these things. It provides SQL-like interface on Hadoop. Now, very important point, Hive does not have storage. It uses the data in Hadoop. For example, you copy a CSV file into HDFS, and what I can do, I can go to Hive, say create a table and give the schema. Then I say load this CSV to the table. What is going to happen? The CSV will be in Hadoop. It is on HDFS. It is as blocks and replicas and all, but in Hive you will just project a structure. So you get a table. Once you get a table, you can do any SQL. Most of the SQL, right? So the idea is to project a structure to the data that is already available in Hadoop. And Hive can create tables from a variety of formats. Structured data, even log files, unstructured data, JSON files. Different types of files can be read by Hive and put it in a table format, right? So that's the importance of Hive. So it's treated as the Hadoop data warehouse system. So the data is in HDFS, and this is just giving a table like structure on top of the data. Hive will just maintain the schema only because the data is already in Hadoop, right? So you don't have to load the data. Even though you say load the data will just become in Hadoop. I'll show you how to load the data. I mean, how to create a tables and all. Yeah, so if you want to run a query, you can directly say write your SQL, say select count star from the table, but the problem is that it will hit Hive, Hive will read the query and it will convert it into a MapReduce program, Java based, create a jar file, so that will take some time. Then when it runs, it's a MapReduce job. And the funniest part is Hadoop never understands what is Hive. For Hadoop, it's a MapReduce program. You're getting the point, right? From the Hadoop's point of view, there is nothing called Hive. It understands only MapReduce. So whether you write a MapReduce or Hive write a MapReduce, it's the same thing, right? If you want, you can write a MapReduce program to query structured data. It's very difficult, that's why we're using Hive. It will translate and create a jar file, push it to the cluster, and the cluster will run the MapReduce regular program, show you the output. You can save it in a table or anything you can do. So you can use all regular SQL statements. You can say insert into a table from this table. So the result will be, if it is matching with the schema, it will insert the same way. The only thing it is projecting a structure. Hadoop only, HDFS only. Everything is on HDFS. It is slow. Hive is expected to be slow. So that is one thing. Hive is considered to be a batch processing engine. So it is not a database. Another common problem is that people may not be able to differentiate between a database and a data warehouse. They are different, right? A database is OLTP, you call transactional, real time, right? Where you want millisecond speed, right? Sub-second speed. That's a database, and you always have insert, update, all these kind of operation. A data warehouse is different. A data warehouse is a place where all the cleaned data comes and lands, right? From there, your reporting tools can connect and visualize the data. Right? So Hive is a data warehouse where you store your final data. So let's say you have a lot of tables, you ran queries and you got the final output, you store it in Hive so that your visualization tools can store it in HDFS, but we say store it in Hive, but it's in HDFS only. Meaning if I open Hive and say select star, I will see a table. If I go to the location, open the file, I see a text file. Same thing. So the text file will be there. If I open and say select star, same text file, it will show me in a nice row column format. And another thing is that Hive's language is actually called HQL, Hive query language. It's not SQL, but it is based on SQL-92 syntax. Most of your queries will work, okay? But it's technically called HQL, Hive query language, right? It's up to us to decide. I mean, so the idea is to familiarize with Hive. Then depending on our business use case, we can write any SQL queries. You can write complex queries, simple queries. You need to have some idea about SQL queries, like what is a join operation, what is a group by query, to understand what is happening. Even a person without knowing SQL can learn Hive. I mean, by looking at a query, you can understand what is the intention of the query, right? Hive is not a DB. Hive queries take minutes even for small data sets and can't be compared to databases like Oracle. Hive does not provide real-time queries. So that is what the original Hive which came was converting into MapReduce. So it was very, very slow. Then came Thais. So what Hortonworks did, they started using Hive plus Thais, which is a bit more faster, right? Cloudera cannot use Thais, so Cloudera still runs Hive into MapReduce. And their answer to that is Impala. Impala is an in-memory execution engine. But Impala will work only on Cloudera. So I will show you Impala and same query will be very, very fast. There is no difference apart from that. I mean, syntax and everything is same actually. So data warehousing in the sense like usually it is used as a storage engine rather than. So what is a data warehouse? A data warehouse is where you store all your massive data, right, structured data, and the intention of Hive is also same, and all the BI tools can connect with Hive. So if you are having something like Tableau, for example, Tableau is a visualization tool. So I want to visualize terabytes of data from Hadoop. I can connect Tableau with Hadoop, and Tableau will be firing SQL queries using Hive, and the data can be visualized. So that's a typical application of a OLAP system. So it's an OLAP system, online analytical processing. It's not an OLTP system. So you can't compare it like Oracle because that's like real time. But again, Hive cannot replace a proper data warehouse, okay. So if you're talking about something like Teradata, for example. So they are like, how do I say, the expensive and fast, reliable data warehouses. Understand, Hive is built on top of Hadoop only. So it has all the drawbacks of Hadoop, right? So most of the organizations, what they do these days is that they will categorize their data, hot data, cold data. The hot data will go to something like Teradata, where they need to immediately fetch the data, run faster queries, and the cold data, which it's okay, you can take some 10 minutes to query, will go to Hive. Hive supports insert statements now. It was not there before. Insert statements are already there, but the problem is that each insert statement will fire a MapReduce job. So you do a bulk load, that's better. So in Hive, normally when you load the data, you do a bulk load, you don't insert it. And the latest editions of Hive support all the CRUD operations, create, read, update, delete, everything is supported. But again, if you want to get the speed, you should use LLAP. That's what I'm saying, real-time queries, LLAP. And LLAP as of now Cloudera doesn't support. So I can say if you are on a Cloudera platform, inserts and updates will be very slow. Not like Teradata. Teradata and all inserts are very fast. But the question is that in a data warehouse, usually you don't have to do an insert. Very rare, right? Because you will do bulk loading of the data, or your ETL tools will be dumping the data there. They will collect data from the RDBMS and then dump it into there. So very rarely you modify the data in a data warehouse. So the use case is like that for Hive. Yes, all the CRUD operations are supported, even insert, update, delete, but it will be slow. On Hortonworks platform, you have ACID support enabled, transaction management, but it is not as reliable as a database, okay, because you can never replace an RDBMS system with something like Hive, but you have transaction management supported. That is all with LLAP. LLAP is the feature which gives Hive real-time performance, but LLAP also requires resources. It requires more resources to execute, but you get all the ACID properties, transaction management, everything. And this is very important to understand. So there is a command line interface for Hive. It's called Hive shell. You can open the Hive shell and start typing your query. Say create database, create table, and then type the query. So that is one way to work with Hive. But people may or may not use it, because if you are in the production and all, you might have some client, right? So what type of clients you use, like to connect with DBs and data warehouses, so SQL Server or Todd or something, something like that. You might either you can use that. So one thing is that you can use a CLI, and Hive is very vast actually, so I am getting confused when I talk. This CLI, there is two CLIs. The original CLI is called Hive, and you simply type Hive, it will open, you do all the blah blah blah. The new CLI is called Beeline. It's called Beeline, okay, and Beeline is a proper JDBC client. So through Beeline also you can open the CLI, or you can simply say Hive, it will open the command line for you. You can do all the create table statements and all. There is a web GUI, but it is very rarely used. Hive is just a client. It's not a JDBC client. So when I open the CLI and say Hive, JDBC, you have drivers, right, to connect. So when you want to connect from an application, right, to a database, you need a driver. That's called a JDBC or ODBC. Drivers are there. That's one way to connect. So the CLI, original Hive CLI is called Hive client. That's not a JDBC client. You just open it, it will directly hit Hive, and it will directly hit the Hive, and you can type all the queries and all. The Beeline is a proper JDBC client, which means you can install it in some other machine. From there you can connect. You can give the server address, port number, and it will hit, right? And it is not written here. There is something called Hive server. This whole part is called Hive server, this part. For some reason in the diagram it is not written, but this whole part is called Hive server, because if you are connecting with a data warehouse, there should be a server component which will accept your queries, whatever you are typing, right? So that is this whole part. So whether you come through CLI and there is a web GUI or JDBC, you all hit the Hive server, right? And Hive server is the component which will accept your query. So once you write a query, there is a planner, parser, optimizer. It will optimize your query and convert a MapReduce program and push it into the Hadoop cluster. In Hive server itself, you have Hive server 1 and Hive server 2. Okay. So the old one is called Hive server 1, which nobody is using now. You don't have to bother. The latest one is called Hive server 2. Okay, that is everybody is using. So Hive server 2 is responsible for managing all your connection. So if you open a connection with Hive, it will directly hit this Hive server 2. And from there, whatever query you write, this guy has a compiler, optimizer, executor. It will get the query, compile it, optimize it, push it as a MapReduce program. Right? I think I can show you that from here. If you go to Cloudera Manager, should be here. It is very difficult to talk about Hive rather than showing something, because talking is fine, but if I show something, probably people will understand more. So if I go to Hive configuration, where is Hive server? See, Hive server 2. So this is called Hive server 2. The default Hive server is Hive server 2, because there was an old Hive server 1 which nobody is using now because of performance issues and all. So right now, whether it is Hortonworks or Cloudera or any platform, the server component of Hive is called Hive server 2. Okay. So either you come through a JDBC client or the command line, you are all hitting Hive server 2. Okay. From there, it will compile your query and optimize your query and push it. And there are tons of optimization techniques in Hive to read your query and better it and all. Probably we will discuss that tomorrow, some of the optimization techniques. Another very important point in this slide is this meta store, this thing. Meaning, if I open a Hive session and I say create a table, if I exit, it should not go, right? Because the table should persist, whatever you are creating. So that is where the meta store comes into picture. That is where all the metadata will be stored. And in production setup, what we do is that we will create a MySQL server, and in the MySQL server, metastore will be configured. So all the metadata of your table, like the schema, access rights, everything will be in the metastore, right? So you have to ensure that the metastore service is running, otherwise Hive will not start, because it needs to talk to metastore. This metastore is very important because even in Spark will talk to this metastore. So if I create a Hive table, I can read it in Spark because it can talk to the same metastore and get the data from there. All the metadata will be there in the metastore. Okay. Metastore is the metadata. Metastore is a service, and that will push the metadata. So you have to give a destination so here it will be there. I'll show you where the metastore is. I don't know where they have configured. If I go here to Hive configuration, right? Hive metastore server thread. Database type is MySQL, right? Yes, this is where it is. See, on this machine they have configured MySQL, and that is where the metadata will be pushed. And we don't have any use of the metadata. Hive will read and write it, that's fine. Okay, and it uses it to persist all the table information and DB you create and everything, right? We don't have much of a use for that, but it is there. And in Hive you have something called a cost based optimizer, CBO. I don't know why it is disabled. Enable cost based optimizer, disabled. It is disabled for some reason, I don't know. So this is called CBO, cost based optimizer. You are aware of RDBMS, right? If you write a very complicated query, it will generate multiple query plans, how to execute this query, this optimizer. So what Hive does, if you enable it, if you write a very complicated query, it will generate multiple plans, and based on the cost of each plan, it will select the best plan. So that is the cost based optimizer. It is disabled. I don't know why it is disabled. So usually you can enable this, and this is how optimization can be done in Hive, right? So this is one thing, CBO. We will look into other things also. Okay, all the configurations are here. To start Hive, you simply say Hive. That's it. If you simply type Hive, it will start the Hive shell. May get some warning, that's fine. And you will easily see a warning saying that Hive CLI is deprecated and migration to Beeline is recommended. That's okay. So what it actually means is that this is the original Hive CLI, and I told you that Beeline is the new client, so they are saying that use Beeline whenever possible. So that's fine. I mean, to learn Hive, I think the best way is this CLI. They have added some more commands in the Beeline section actually, because the old Hive CLI support is getting lower every day. But for learning purpose and all, it's all the same, whether you use the CLI or Beeline. I'll show you how to use the Beeline also. So this is the Hive shell what you open, right? And it's very easy to get started with Hive. All you can do is that you can start by creating a database. You say create database. So first thing is that we create something called a database, right? That is the highest level of abstraction. So I say create database, I don't know, something May 19th. So I just created a database. So the command is create database and the database name. So I'm just calling it as May 19th. And if I do a show databases, you can see a lot of DBs are there. People have created, right? See here. So these are all the databases that got created inside Hive, and mine is May 19, right? You could have created something else, right? Whatever, I mean, you remember. And you have to say use to switch the DB. You have to say use May 19. These are regular commands if you are aware of SQL, right? There is a way to show that. It will display the DB name. Set Hive. There is a property where we can enable it to see the DB. I'll search for it. You can even print the column headers. So normally when you say select star or something, it won't show the column headers, the column name. You have columns and the names, right? It won't show, but you can make it show. There is a command to print that. So first we'll make sure everybody is on the same page. Hive print current DB. Set Hive CLI print current DB. So this is how you can print your DB. You simply say set Hive CLI print current DB equal to true, and then it will display the DB there. Can you try this? Everybody is able to log on to Hive and start and all. Anybody having problem? In Python you don't have, right? No, you have indentation. Indentation is very complicated actually. You miss one indentation, nothing will work in Python. I know that a lot. Very difficult. People who are coming from the Java world and you are familiar with curly braces. Here everything is, you start a control structure, there is an indentation, right? But the editor will take care of it, I think. If you are using some editor. That will be in the metastore. Only the definition, right? Metastore will have it. All is the same. That's what, when you normally start Hive, I said the use main 19, right? That the DB, it won't show me in which DB I am in. So now it is displaying it here, right? See this. It will show in bracket what is your current DB. So it will display whichever database you are in. If you change, it will show, right? And another important point is that probably towards a little bit towards admin side, there is a file called a Hive site XML. Hive-site.xml, and that file has around 1000 properties, and the whole Hive is controlled by that file. So these properties are actually from that file, meaning either you can do like this, you can open a session and say set Hive blah 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 true, but if you exit and re-log in, it will not print the DB. Again you have to type this, or you can ask your admin change in Hive site XML this property, so that for everybody who log in the DB will be visible. So that file has lot of properties actually. I'll try to find that for you. Problem is that I was with Hortonworks for the past 10-15 days. I'm finding it bit difficult to read Cloudera, but it will be here. Configuration. Or do one thing, no, it's easy. What you can do, all of you can do, open one more command prompt, web console, and just copy. If you go to cd etc hive conf, yes. If you navigate to this location, this is common for Cloudera, Hortonworks, everybody. etc hive conf folder, you will have a file called hive-site.xml. This file controls end to end of Hive, all the properties, right? And if I open it, you can see all the properties. See, Hive Metastore URI. This is the Metastore URI, remember? So where the connection is there, then some other things are there, auto convert, join. How do you search in VI editor? This one, right? Then I can type, right? What did we set now? Hive CLI. Oh no, Hive dot. It says pattern not found. It should be there, right? I mean, I'm just wondering. Or what if I search DB? Saying pattern not found DB. Should be there. Let me just search for Hive. Probably, I don't know. See, all this, what you say, properties are there in this file. Probably some of them are, so another thing is that you are accessing this file locally. I mean from this machine. If I go to Cloudera Manager, configuration, I'll say DB. Should be there somewhere. I think some of them are actually not visible to us, but all these properties are read from Hive site XML. All these things will be in Hive site XML actually. So that is how you can print the current DB you are in. Well, that's not our intention. What is our intention? So let me show you the data that we have. So if you go to this folder, right, you will have two files. Now, once you start loading data to Hive, it is very complicated. Even though the queries are very simple, people try to get, it is like watching a Christopher Nolan movie, you know, you won't understand what happened after, once you finish the movie also you won't understand what happened. So the point is, I will write first, then probably we will do it, okay. So you will create a table that everybody knows. This you will do in Hive, you will say create table blah blah blah, it will create a table, fine. Then next step is that you want to load the data into the table. The data can be loaded from local file system or HDFS. It's a bit tricky. So if you create a table and you want to put some data, right? The data can be loaded from Hadoop or from your Linux file system, right? Okay, and I will show you what will happen, how to do both this and what is going to happen if you do both this, what will happen to your data and all these things, right? So we'll do step by step, otherwise people get confused a lot in this stage. It's actually very easy, but end of the day people get confused a lot. Where is my data? What happened to my data? Sometimes you will get local also. So what happens, these ETL tools and all, sometimes they dump it into some local machine. You can load. You can say Hive, take it from my Linux, dump it into. So it is actually copying from Linux to Hadoop. But there is a way to do it, that's what I wanted to show. So let's look at the data, right? We'll also do some small analysis. Can you open this file? But I need a better editor actually. WordPad will do, right? That file is already available in your data set. Let me download this, okay, real quick. Can you see this file, transaction.txt, txns1? It will be here. You will have a code and data folder. Inside that Hive, inside that. I think it is a .txt file, right? Because for me the extension is not visible. Just give me one moment, I'll just install this Notepad++. So last class you are watching Narcos or what? The ads are coming, right? What happened in the morning? So what we will do is that first we will copy the file to the local file system, that is Linux, and then we'll create a Hive table. We say load the data to the Hive table and we will see what is happening in that process. Then, so there are two files actually. Another file I'll copy to HDFS. From there I'll load to another table and show you what is happening. It's okay, we'll try without this. I mean, you have Notepad anyway, right? So that's fine. I just wanted to show you this. Yeah, so this is the transaction data, what we have here. And if you look at this data, right, I'll just take one line and explain what it is so you can understand, right. So if you take this line, so the first column is the transaction ID, that's nothing but 18. Then you have the transaction date, then you have the customer ID. So 4002444 is customer ID, okay. And then you have the amount spent, $88. Then you have the category of items he bought, team sports, and what actually he bought, baseball, city of Salt Lake, state of Utah, and credit. So it's a typical sports store transaction. What category, what item, what amount, credit, debit, you know, and you have n number of lines like that. That's okay. That's okay. No problem. So this is one data that we have. It's a transactional data, and we want to create a Hive table, load this data. So that's one thing. Second data that you have, there is a file called a cust. Can you see this? And I want to open this with WordPad. Yeah. So this is the customer data. So first column will be customer ID, first name, last name, age and profession. Christina Chung, age 55, is a pilot, like that, right? So you have a store customer data, you have a transaction data, right? And what we want to figure out is that we want to figure out the total amount spent age wise by the customers. For example, I want to know in my store what is the total amount spent by people aged between 20 to 30 and 30 to 40 and 40 to 50. So that is the analysis we want to do. So in one data set we have all the transaction, like how much amount they are spending and all. Second data set we have the person's name and age and all. So we'll do a join and then we will do a case statement and figure out. That's what we are going to do. So the SQL analysis is not the intention. The intention is to show you what is happening behind the scene and how Hive is dealing this, right? Okay. So now what I want you to do is, first we will do only the local. So we will copy the data to the local file system. From there we will analyze it. So I want you to copy these two to our local system. So how do you do it? You have to open the FTP stuff, right? So I will just say FTP login and hopefully it might work for me. Upload files. So upload these two files. One is called cust, C-U-S-T. Another one is called txns1. Open. Yeah, so it works here. Okay, I need to open one more. Okay. Luckily for me, it is available. You have to figure out. So use FTP and copy the files to Linux, not to Hadoop. Don't upload to Hadoop. I'll just wait if you need some time. Yeah, but we don't have to change the extension. Yeah, so if it is a text file format, it can access any text file. Only thing you have to mention the delimiter, comma or whatever it is. So Hive can handle text, CSV, JSON, XML, variety Parquet. So there are multiple file formats it can handle. So by default it will read all the text, but if you are having JSON and all, there is. So are you guys familiar with something called SERD? Have you heard about SERD? No, SERD stands for serializer deserializer. Okay, it's a very common practice. So what will happen is that, let's say you have a JSON file. You know what is JSON, right? Key and value, like key value pair. So if I have a JSON file, I can ask Hive to create a table from that. But the problem is that JSON is semi-structured data. It's not proper comma separated or something. And Hive will say, I don't know what you're talking about. I can't find a schema. So to do that, we can use something called a JSON SERD. You have to download it. It's a jar file. I don't know whether the latest Hive has it. If not, you have to download a jar file which is called a JSON SERD. Okay, add it into Hive, and then you say create a table using the SERD. So using this SERD, it will parse the JSON, and key will become the column, value will become the data. Like that. So SERDs are used to read semi-structured, unstructured data. I will show you an example of unstructured data where you can use something called a regex SERD. Regular expressions you can use to parse the data. So Hive supports a number of SERDs actually to read different types of data. JSON I will see, if I have a data I'll show. So that is again an open source projects, most of them. So internally nothing happens. They will read the key and the value if it is a JSON SERD, and it will give that structure like a table to Hive. So if Hive looks at it, Hive will not see as key value pair. Hive will say a column header and a value. It will just apply the same thing. So it is reading the semi-structured data and giving a structure to that. It is a parser. So we have parsers, right? It's a parser actually. So this thing are you able to do? Are you able to upload, everybody? And find this file. You have a file called commands. Can you see whether it is there? Just commands. In the Hive folder, you will have a file called commands. No. This is not, this is the commands we have to type or copy paste. So we don't have to upload it. So this is in the, for me, this data is in the folder called Raghu. Okay, that is where the data resides. Let me close this. Now we can actually create a table. So let me just copy paste this. You can, so don't do a create database, because the first two steps we have already done. We created a database and then we said use it. Okay, and the first thing you need to do is this command. I'll explain it. So just copy this, create a table, just go here and paste it and add a semicolon at the end and hit enter. You have to add a semicolon, otherwise it will not work, and hit enter. Yeah, so this is the typical create table command in SQL. It says create a table and then the table name is transaction records or whatever name you want you can give, and within the brackets you are mentioning the schema of the data. So Hive supports simple and complex data types. So those who are aware of data types, so you have simple data types like integer, string and all. It also supports complex data types like maps, structs and all, right? So they are all supported, but here we are just starting with a very simple. So I am just saying even there is a date data type, and the important point here is not the schema I am mentioning. You even have a data type for date. I am not using it, I am saying string, but Hive supports date handling and all. So after that, the most important point here is row format delimited fields terminated by comma. What that means, Hive is expecting the data in row by row and the delimiter is comma, which means you can load only comma separated files ideally, right? I'll tell you what will happen if I do something else. Let's say I am not using comma, what will happen? I'll show you, but right now we are simply creating a table. There is a record reader for Hive, so that will read, no, we don't have to define, okay. So now this table is created, right? So all of you have created. Hive can be accessed through Hue. You have a Hue, right? That I'll show you that. There you have autocomplete mostly, but the hard way if you are working with Hive, there is no autocomplete. You have to type everything manually. Now is the important thing. How do you load the data, right? And there are a lot of things I want to talk about loading the data. First of all, identify where is your data, right? So in my case, the data is in this location. So just make sure you understand the location of the data. In my case, this is the location. I'll just copy this, and the data is txns1.txt, and I will say load data local in path into table. So this is the command. The path I found here, I went to this location, I did a pwd. See, this is where I have the data, right? It is on Linux. It is on Linux. And it is very easy. If you make any mistake, it will say path cannot be found, it will not load. If there is a correct path, it will say loading the data, right? It's very easy to identify whether the command is correct or not. In my case, see, it says loading the data. So that means it is working fine for me. Are you also getting the same thing? So make sure it's a local path, okay? So people get confused, it is a local path. Yeah, because here we have not done the analysis, we just loaded the data. And here you can write SQL query. You don't have, we'll be writing SQL query. You don't have to write the Java program and not at all. You don't have to know Java, jar file. It will create a jar file actually. If you mention a folder, it will load all the files in the folder. So just mention the exact file. He mentioned the folder name. So there were 2 files. It loaded everything. So here, since it is a data warehouse, it just appends 2 files. But from where to truncate, there will be another problem, right? Even I don't know. This should be the file size in bytes, I think. Roughly it is 4 MB, right? Should be 4 MB, the size of the file actually. Now this part is fine actually. I mean, you are just loading the data, and if you want to check, you can simply do a select star from TXN records. You can do a limit 5. Can you try this? Do a select star from the table, do a limit 5. Don't simply run a select star. There is around 50,000 records, I think. So do a limit. I want to see the top 5 rows, right? So that's the command. This is to make sure the data is loaded. Now you can upload the data from local as well as Hadoop. So I'm just showing how to do this. I'll show you from Hadoop also. Both possible. No, select star means select everything from the table. I want to see the full table, right? Limit 5 means top 5 rows I want to see. Now if you actually want to see the query, right, you can write any query, doesn't matter, but I can simply say select count star from. So this select count star is a query, and as you can see, the moment I run the query, it is firing a MapReduce job. See, so the query will fire a MapReduce job because it is converting it into NC map 0, reduce 0, and this cluster is really good. What I'm telling you is that we have around 10 nodes here in the cluster, and only I think around 20 people are using it. Very less data. That's why it is very fast. Actually, it is very slow. This is unexpected. If Hive is fast, there is some problem. You have to troubleshoot. So this means select star. Select star means show me the full table. Limit 5. I want to see the top 5 rows. You are just verifying the data is loaded. No, the top 5 rows. Because it has 50,000 rows. If I simply do select star, it will display 50,000. I don't want. I just want to see. No. Select will not fire a MapReduce job because it's a simple read. It doesn't need to do any calculation. So when you do a select star, it won't fire a MapReduce job. It will simply show you the output. So just let me know, are you able to do till this? You have to do a select count star. It should fire a MapReduce job, and you should see the output. One more thing I want you to do, in that file I have given to you, right, this commands file, it might be slightly wrong, not wrong, don't copy paste. That's what I am saying, that I'll write it here because I use it for a different session also. So there, if I open this, here it will say load data in path. See, it is saying load data in path. It is actually load data local in path, right? So don't follow the same thing, and you can correct it also. Whatever you are running here, just correct it there so that it is reflected, right? Otherwise tomorrow you try and it may not work the way you expect. Because it's the MapReduce output. I mean, it is firing a MapReduce job, right? So MapReduce logs are just being displayed. That's what. You can suppress it. There is a way to suppress it, but normally if you submit a jar file, MapReduce, it displays the same thing, mapper, reducer. That's one. Finally you will see the result also. It is a default nature actually in Hive, because even though it is a Hive query, it is not a Hive query, it's a MapReduce program. That's why it shows map, and this is good for troubleshooting. Sometimes it will show you errors and warnings and all when it is running. I'll show you how to enable column, but right now, oh, you are doing a select star, right? If you want column names, set hive.cli.print.header equal to true. Okay, now if I do this is count star, right? It will call. Definitely, because it is some analysis, it has to call for it. Only the select star will not call because it is just reading the data. So are you able to load the data, at least run the basic query? Then that's okay. I mean, he is asking, can you see the Java code Hive is writing? No, I have not found it so far, how to do that. No, that is internal to Hive. I mean, how it is converting that into a Java pro. Actually, we have all this in MapReduce. For example, how to write a join in MapReduce is there. A select statement doesn't, normal select star is simply showing, right? It doesn't convert to MapReduce. Where condition. Internally, there should be some logic again to, everything is key value pair, end of the day. Everything is, so another drawback is that Hive is good, but you will not know what is happening behind the scene. Like, end of the day, how the code is written, you will not know. You will see the result, but that's enough. If you know SQL, you can just fire the query, right? Hadoop into Hive, in Hadoop, to Hive and Hadoop, because it is in Hadoop and it is visible in Hive. Anyway, so that now the important point is, I don't actually want to show you running the query. That's so once you now you have this table and you can write all the SQL query. That is not my intention. The real question is, where is the data? First question, right? So you loaded the data and from local you said, that means from Linux. So first thing you have to understand is that data must be in Hadoop. So when you did a load data, it could have gone to Hadoop, that's for sure. But where in Hadoop, right? So to understand this, what you need to do, you have a describe command. So let's say describe and txn records. So this is a very common command. If you do a describe on the table name, it will show you the columns and data types and all. And if you want, you can also say describe formatted and the table name. So describe formatted will give you more details about your table that you created. And if I hit enter, there is a very interesting thing that you can see. The thing is, it says table type is managed table. So any table that you create in Hive, either it can be a managed table or something called external table. By default, everything is managed table. I'll tell you what you mean by managed table. Okay, but you can clearly say, see, it says it's a managed table. Point number one. Point number two, it displays something called location, right? It says location and it says user Hive warehouse. So I want you to do one thing. Just go to your Hive file browser. Can you go to this thing? If you go to this Hive, just go to this user folder. There is a folder called user. Can you go here? Oh, I think there are a lot of users actually. So n number of users are there. Okay. So do one thing, user / Hive. So if you simply type it here, user / Hive, you will land on this page. So what will happen is that when you install Hive, there is something called warehouse folder. Hive will ask you where to create it, and normally in all Hadoop clusters, it will be user Hive. Inside that, there will be a folder called warehouse. Okay, and if you open this folder, you can see all the DBs people have created, and you can open your DB. My database was May 19, so this is my database, May 19. Open that, and there is a folder called txn records. This is nothing but your table. You open this, you have the data. So try to find out your data by yourself. So my point is, what is going to happen whenever you are creating a DB in Hadoop, this folder is there, user Hive warehouse. Inside that it will create a folder with your DB name. When you create a table, a folder with a table name. And when you say load the data, it is simply copying the data here. Are you able to reach this point? I mean this place. You can also do something interesting. I can simply go here and delete the data. I deleted the data from here, right? And if I do a select star now, oh sorry, it fired the query because the table is there. It will say 0 because the data is not there, right? So let it run. Yeah, so or if I do a select star, there is nothing. So I did a select star from the table and there is no data because I deleted it from here, right? And you can manually copy the data here. If you don't want to type load data local in path, I can just copy this transaction here to this location. That is a schema, but you don't have a data. So now I manually uploaded the data here, and if I go back here, I should be able to see the table. So this is where your data goes if you are copying. If you are saying load data local in path, the data goes into this user Hive warehouse DB folder, table folder, that is where it dumps. Okay. So are you able to see this folder? I think yes. And now you are now I am going to confuse you. Okay. So if you understood this much, I am going to confuse you. So now what you did, you loaded the data from local file system. And I have one more data, right? So there is one more file called customer, right? I want to upload this from Hadoop. So what I am going to do, you can also do along with me. I'll go to Hue, okay, and in my home folder, Raghu, okay, I'll just upload the data here, step number 1. So where is the cust file, customer file? Copy that into Hadoop in your home folder, wherever you want. This is a bit confusing, I mean, so remember the location where you have copied that in Hadoop. Fine. Uploaded. And now I want to copy that into customer table. But first we have to create a customer table, right? We don't have a customer table. So I can go here and there is a command here, create table customer. See, find sales based on age group. Below that there is a command. Just copy this command. Come back here and just say paste it. And it should create a customer table. Fine. So now you can load the data from Linux. You already know how to do that, okay? But I don't want to do that. I want to load from Hadoop. How do I do it? I'll say load data in path. I don't say local, I say in path. I'll say Raghu / custs into table customer. Try this. Only difference is that you are not using local. You say load data in path and give the Hadoop location. Now I want you to do one thing. Where did you upload your data in HDFS? This cust file. Can you check the data there? It will not be there. If you can see, there is a problem. It will move from there. Just see once. See, in my case, it was in Raghu. If I refresh here, it will be gone. Because the tables we are creating is called managed table. So when we did a describe, it showed it is a managed table. What is a managed table? A managed table is a table where Hive will manage your data. You don't have any control. So in Hadoop, it has already selected a location where it will dump all the file. So even though you say load the data from this Hadoop location, it will cut it from there and dump it into that. So you can go back to that user Hive warehouse folder, there your data will be there for sure. You don't have any control as to where the data will be. Hive will control it. Try whether you can see the data there. In user Hive warehouse, this location. No, never. It's just a projection. It's just a pointer, that's all. It's just a projection. The metadata will get updated. That's what is happening. Because when I say move from this folder to that folder, rather than moving that, name node will update the metadata. It will point from here to here. That's all it is happening. It is there. I mean, other place it will be gone. Where you have already uploaded, the data will be gone. This will not happen if you are loading from local. It will not delete from local. Okay. So that's a bit confusing, but that is how it works. I mean, people will think, hey, where is the data? What happened? Where was my file? Right? Because it is managing the data. So it will not allow you to keep the data. It has to be in the user Hive warehouse directly. So that's one thing, and that's called a managed table. What we are creating is called a managed table. And now ideally, if you have done everything correct, like I am doing, if you do a show tables, you should see 2 tables, and you should also have data in both the tables. Can you verify? Do show tables, and if you do a select star, you should have data in both the tables. Because then only you can do further any analysis what you want, right? Once you have the data. But here we can use SQL. You are not familiar with SQL, I guess. SQL is the most powerful language in the world for analysis. There is nothing which can beat SQL. Even though I don't know much of SQL, I am not a SQL guy. So you might have to write complex queries, but end of the day, that is not the idea. You should know what's happening. Queries anybody can write. Maybe you don't know how, even I don't know how to write some queries. So I'll take help, or somebody will write the query. But if you fire a query, what is happening, where it is running, that is. I'll tell you a very interesting story. I have a friend of mine, he is working in Cape Gemini. So I went to train in Cape Gemini. So he was in my training team. He is my friend. He was also sitting in the class. I knew that, okay. So I was asking the participants, how many of you are using Hadoop or Hive, or, and most of them said no. They are all ETL guys. The point is, they were running Hortonworks, and Hortonworks has a tool called Hawk, H-A-W-Q, Hawk. Hawk is like Hive only, but with some modification. Like Hawk has become LLAP now, to be fair. Previously they used to call it as Hawk. Okay, so Hawk is actually a connection to Hive only, end of the day. So these people were using Hawk for past 2 years, but they didn't know that they were using Hadoop. Because for a SQL developer, it doesn't really matter. You write a SQL query, and do you really care where it is hitting or who is processing your query? You don't really care. Your idea is to run the query, right? A Hawk as such is LLAP. So Hawk is an improvement on Hive, and now the project is discontinued. It has become that LLAP, real-time ACID queries on Hive. Previously it was known as Hawk. So I went like 3 years back. That time they were running Hawk, and they didn't know that it was Hadoop. So most of their queries were on Hadoop. But that's what I'm saying. If you are a SQL developer, mostly you don't really care where the query is running. You care where the query is actually running or not. There's a problem or there's a performance issue. That is what you look into. So that's what I'm saying. So I was asking them, do you actually use Hadoop? They said, no, we have never used Hadoop. They were actually running queries for 2 years almost. Okay, so once you have the data, what we want to do is, see, I want to do it in a different way. You can do it in many ways. First thing I am going to do is that I am going to create a table. So you can get the commands from here. It's called out1. So I am creating a table called out1. If you look at the schema of this table, you will understand what I am doing. It's a join table, meaning I want to do a join and I want to store the result in this, right? So usually you don't want to ideally push it into a table, but you can do it also. So I am creating this empty table to store my join results. So I'll be doing a join operation and this table will hold the result. And how do you do a join query? It's very simple. So if you know SQL, I think this will be very easy for you. You will do a insert overwrite statement, table, and it's a typical inner join, right? You will say a dot customer number, first name, age and profession, that is from one table. B dot amount and product, that's from another table. From customer A, join transaction records B. On the joining column is customer number. So for those who do not understand this, we are merging two tables. So this will produce a result, but we want to store it somewhere, right? So we created an empty table called out1. So there it will push it. So this is a typical syntax of a join. So that A means 1. From A here is customer table, B here is transaction records table. So from A table I want columns customer number, first name, age and profession. B I want amount and product. And whenever you want to do a join, there should be a common column. Then only join makes sense. So the common column here is customer number. This one is the common column, customer number. And this is called a simple inner join. You have outer joins, left outer, right outer, full outer, all this, everything will work. No, now it is insert overwrite. Now the table has no data. It will simply dump it. If you already had some data, it will delete everything and load it. You also have an append where you can simply append. Okay, for SQL guys, I have a question. Just I thought I'll bug you with questions. What do you mean by schema on write? Sorry, schema on write. Do you know what this is? If yes, what it is? Your RDBMS and typical systems are called schema on write. Meaning, if you create a table, let's say the table has 6 columns. If you try to insert 7 column data, what will happen? It will say violated. You cannot insert 7 columns to 6 column table. That is because it is called schema on write. It will validate the schema while you are writing the data. Hive is schema on read, not write. Meaning, I can create a Hive table and upload an MP3 file. It will properly upload, no complaints. I can upload a movie, properly upload it, no complaints. Because it will not validate what you are uploading, right? You will say load the data, it will simply copy that and dump it in the folder. But when you query the data, it will validate. There it will show an error saying that, okay, and why it is because, why Hive is schema on read is for faster uploads. Because otherwise if it is validating everything, it will take time to load the data. It's a data warehouse, right? I think most of the data warehouses are schema on read. I don't know much about other things, but Hive is definitely schema on read, right? So schema on write is typically on your traditional systems. So run your join query, see whether the join happens. It's faster. So Impala will be more faster, I think. If this is like this. Now if Hive is faster, there is some problem actually. We have to troubleshoot. Ideally we do it. Select. So now verify the data actuals. You do a select star from out1 limit 5. So you should see the join output here, and as you can see, you are having these details from the customer data like Cameron 59 actor, and these details from the other table, right? Like the amount and the product. These things are from the transaction table, right? You should see the join result. So now you have joined the table. Join two tables actually. And now what I will do, logically speaking, what I will do is that I will use something called a case statement in SQL. So those who are aware, it's easy. For others, what is a case statement? Very simple. I will say that look at the age column. Okay, if age is between 20 and 30, categorize the customer into something. 30, 40, do something. So because you want to group them, right? Then only you can sum the transactions. So in SQL, you can easily do that using something called a case statement. Okay, that's what I'm going to do. So, but to store the output, probably I'll create a table. I'm just creating intermediate tables. So create this table called out2. So this table is called out2. And if you look at the schema of this table, there is a last column called level. This column does not exist before because that is the place where the case will push the result, right? So that level column will have low, medium based on the age of the customer. I'll push the data there. Okay. And how do you write a case statement? This is one way to do it. So I will say that select everything and I will open a case here. When age is less than 30, I will mark the customer low. Age is 30 to 50, middle. More than 50, old. Else, others. So this is how the classification will happen, and that will add to the last column of our table. Now by default, simple case tense, it will go to the last column only. If you are writing a simple case, it will have the last column added where the conditions will be added, whatever condition you are mentioning. So here I am just saying that only low, medium, high, right? Three categories I am mentioning. So see, this is the case statement, right? And Hive is full of SQL. I can't really help it. I mean, there is no other way to write in Hive, right? Without using SQL, I cannot write anything in Hive, right? So don't worry if you don't understand SQL, but get an idea like this is what will happen if I do it, because Hive is extensively used. I mean, most popular tool, I can say. So that means we are in the last part. Now we have created this table called out2, and if I do a select star from out2 limit 5, see, now if you look at the last column, every customer is classified, old, middle, right? And now we will do something called a group by query. We'll just group them based on low, middle, sum all this thing, and you will get the final output. This is just to show you how Hive is running, okay? No other. And to do that, I will create a table called out3, and I want you to tell me the query. Let's see how many of you can tell. So this is the third table I created. Okay, group by you know, this, what is that column? Level. Yeah, so I mean, I'm just asking. So what we are doing here is we are simply selecting the data, grouping it and counting it. And now the final table, if you do a select star, you will see the final result. Select star from out3. So now you can see low, middle, old and total amount spent. So who is spending more? Not low. I think this is bigger, right? Older. I think older people are spending more, actually. I don't know. Maybe, right? Huh? Based on what you are selling. Retail store, right? Sports items. Probably older people are actually selling, buying more these things. Now, quite interestingly, if you don't want to open a shell and type all this stuff, you can go to Hive. There is a query editor, and there is Hive. Same thing, but you can go to this Hive, and in here you can select your DB. Yeah. So it is a default database. Go back. Oops, cancel. My database is May 19th. So I am in May time, and here you can do the same thing. Select so now it will do autocomplete and other kind of things a little bit, right? Just say play. See, if you just hit play, it will do that. So this tool called Hive is very useful actually, because that is one thing. Apart from that, let's say I take a query. So we have a table, right? Out to, right? Select star from out to, let's say limit 50, something like this, right? And if I run this, the query runs and it gives you options to visualize. See, you can visualize the data. I mean, right, this is Hive's property. No, in my knowledge, no. There is a website called gethive.com, but they are available on all the Cloudera. By default has Hive. If you buy Cloudera, you get Hive. Hortonworks doesn't have Hive. You have to separately install if you want. Hortonworks has this Ambari UI, which is very good. Ambari is their admin tool that has a file manager, same like this. You can click and upload the file. That's very good actually. Hive is third party in my knowledge. Ambari is from Apache. Hortonworks is just using it. Even on Apache Hadoop, you can install Ambari. So if you are having a plain Apache Hadoop, you want to administer it, you can install Ambari. But popularly on Hortonworks, because nobody uses much of Apache Hadoop. You are either Hortonworks or Cloudera, right? MapR has the worst UI. It's called MapR Control Center. Worst. I mean, I'll show you the UI of MapR. I had a MapR cluster. I lost it. MapR control system. I don't know, maybe they have improved. No, they have not improved. MapR's UI is called MapR control system, MCS. Okay. Yeah. This is how it looks like. See how weird. I mean, this is their, like Cloudera manager you see, this is their UI. Very dreadful fonts, and you can't find anything in this. I mean, the worst UI ever created probably. I mean, comparing it to the Cloudera manager and all, Cloudera is way better. The UI, fonts, everything. This is MapR's control system. Their UI. Anyway, I wanted to discuss one more thing. So far we have done manage tables. I want to talk about external table, and that is again a bit confusing. Okay, we'll finish external tables and wind up probably. Okay, you had been through a tough session actually. So just do one thing. I want you to do one small thing. I want you to create a table. Okay, so I am copying the command from here, and I want to change it. So just open one more notepad. Open, sorry, new, right? So this command is for creating the transactional table, regular command. I just want to change it. I will say create external table, and I will say transaction records underscore ext. Okay, and then I will say location. I'll explain what I'm doing. Okay, first let me try this. Control C, my data. So I'll just copy this and see whether the command is working. Then you can also try. Yes, it works. So you want me to increase the font. Let me just increase font. Amount double is there, just only one thing. So what is the difference here? You are creating something called external table. First thing you can note down is that you say create external table. So there is a keyword called external you are using. Point number one. Point number two, after all the schema and all, I say location. In location, I say user GL faculty, that's my home folder, my data. What is going to happen if you run this command? It will create a table, that's for sure. It will also create that folder for you, my data, in Hadoop. I don't have that folder, but it will create that folder for me. Let me show you. I'll tell you why it is required. If I go to my home directory, where is it? Yeah, here it is, my data. Can you see? So this table is, this folder is created by my table creation command. I didn't create it. Okay. Now what is the idea of an external table? When you create an external table, you have the control as to where is the data. So right now there is a folder called my data, right? And all I need to do is open this folder, okay, and copy my transaction files here. Sorry. Just copy this file here. I'm just uploading the file, and if I say select star from txn records underscore ext limit file, I have the data. So the difference here is that, what is the difference between managed table and external table? In managed table, you don't have any control as to where is the data. You just say load the data, and Hive will always keep it in user Hive warehouse, blah blah blah. In external table, you say I want a location where I will keep my data. So here I mentioned a folder, and I can upload all my data here, and that will appear in my table. More than this, so this is one example where we actually use external table, is that customer will say that they will have some data, and we will ask where is your data. They will say my data is in S3, Amazon S3. You can simply say create an external table, point to Amazon S3 location. All the data will appear in the table. The data will be there. I'm saying you can see that in your table. So any external location you can keep your data, and you can access in the table. That's called an external table. Try this if you want. Create an external table and upload the data, see whether you can find it. Because all the times you may not have control on the data. You cannot say that all the time I will copy the data to my place. Sometimes you might want to create a table and point the data, point your table to a folder. Actually, that is possible. From my local system, I upload it to that folder. So once you upload the data to this folder, it will appear in the table, my data folder. The data has to be in this folder, then only you can see in the table, because you are saying the location is there. See, the business use case is different. I'll show you. I'll show you the business use case, okay? So what is going to happen is that, let's say you are having some DBs. So here I have an Oracle Okay, here I have some MySQL, etc. Right? And what you do is that, so you have some databases, right? And you, let's say, run Scoop. You know what is Scoop, right? Scoop is your ETL tool. You say, hey Scoop, do one thing, connect with these DBs every day at 12 p.m., 12 a.m., midnight. So I can schedule a job every day midnight. What Scoop will do? Scoop will connect with these two DBs and it will run the ETL job. It will pull the data from here, and once Scoop gets the data, Scoop has to send it somewhere. So I have my Hadoop cluster here, right? There is my Hadoop cluster, right? What will do? Scoop will dump this data into a folder. So there is a folder called, I don't know, Raghu. So Scoop will keep on pushing the data to this folder called Raghu. Now I can create an external table, okay, and point that location to Raghu, right? So what will happen? When I do a select star, automatically the data that Scoop is dumping here will appear in my table. Are you able to understand what I am saying? So typically in an ETL leg, what is happening is that every day you will be running ETL jobs to bring data from multiple places, and all this data will get dumped into some folder. Now somebody cannot go there and say load data local in path. Rather than doing that, you create an external table, point to that folder. So the moment the file lands, it is appearing in your table. Very simple. That is actual use case of external table. Scoop cannot do scheduling, Uzi has to do. Now if you are asking, Scoop can directly dump it into Hive tables also. It is possible. Scoop can take the data from Oracle, dump it into a Hive table. That's possible. But many jobs are there where you get data from multiple sources. Say you are a Flume job. If you are running Flume agent, it may be collecting log files. All these log files will dump it into some folder. Now I can create a simple external table where I can use some serde to read the log, and I simply do select star, all the data will appear in my table. Otherwise I have to say load data local in path every time to dump it into this table, right? So the actual use of external table is that, you can simply point to any folder and all the files will appear in your table. So Hive doesn't care what is inside that. You have to make sure that the schema matches everything. And some people ask this, what if I have a 20 column data in the folder and you have a 10 column Hive table? The first 10 columns will come. It will truncate from there, ideally, okay, because it just fits wherever it is possible and then it will remove it. So all the files will be appended in the table and shown, like 5 files. Wherever your records it cannot match or cannot understand, it will say null values, I don't know what it is, or data types mismatch. Only 5 columns will come. It will try to fit, but there is no guarantee, right? So ideally that is not a use case, because in a data warehouse you are not supposed to do it actually. You are not supposed to experiment in a data warehouse. The data should be clean. That is why you have this cleaning, pre-processing, data factory operations and all, right? Then only you take the data to a data warehouse finally. And another important point about external table is this. So if I do a show tables now, I have this table called transaction records, and this is a managed table. This is my original table. I say drop table txn records. I drop the managed table. Can you tell me what will happen to the data? Will it retain the data or data will be gone? Data will be gone. Sure. No. Data will retain. Data will remain. Okay, I am just asking. So I just dropped a managed table. You know what is a managed table? I am asking, table is gone for sure. The file I manually uploaded, right? Will it be there? Yes, no. 50-50. We'll check. User, where is it? Hive warehouse. May 19. Do you see a folder called transaction records? The data is gone. So manage table has this drawback. I won't call it as a drawback. So this is very common. It happened once in a project where I was working, and that is how I came to know. I mean, normally when you work, you don't learn these things. You learn by mistake, somebody does. So we had a table, very huge table, which was shared among our project. 2-3 projects were sharing this table, and they had full rights. That point in time, one of the engineer, he said drop the table, and then it's gone. So he said drop the table accidentally. He didn't intentionally do it, but the problem is the table is gone. But they had some recovery mechanism at that point in time in Hadoop. In Hive there is no way to recover. So, but ultimately it's a delete from Hadoop. So they had some recovery trash mechanism, recycle mechanism, and based on that they recovered somehow. Okay. That is why when you create a table which you want to share, always create an external table, drop table. I can just use the up arrow, right? What is the table name? Transaction records underscore ext. So I'm dropping the external table. Table is gone, and I'll go to user. I can just go to home folder, right? I'll go here, and we had a folder called, what was the folder? My data. The data remains. Because Hive does not have any control on your external data. You have control. You upload it. It will not delete. So this is easy. You can recreate the table. Data will not be lost, right? So if you want to share the data, expose the table, always create external tables. Managed tables are very rare actually. For learning purpose, we say it's easy to do managed table. And in the operation side, they are all the same. The queries and everything is same, managed table. There is no difference. But always remember, create external tables if you want to share this. Okay. This PPT has more data. I request you to go through that. Also, the official website of Hive, very, very important, hive.apache.org, and it has tons of information. Okay, like I don't know how much it has, lot of things actually. You can start with getting started guide on Hive to understand what is Hive. Yeah. I forgot how to connect using Beeline. So I'll show you tomorrow how to run Beeline, because I just want to see, by default Hive server 2 runs in port number 10,000. So when you're starting Beeline, you have to say JDBC connect to 10,000 port number, and then it will connect with the Hive server 2. I will show you how to do that tomorrow anyway. I forgot. So please go through this Hive official website. It has tons and tons of information. Lot of things are there. There is a Hive wiki page which we just saw, right? And just look at these points we already discussed. Query execution via Apache Thais, Apache Spark or MapReduce. Oh, probably last bit I can show you Thais, but I forgot my username and password. It is not here, right? I'll show you tomorrow Thais. Anyway, query execution via Thais, MapReduce or Spark. Hive can use Spark as an execution engine, but people don't prefer it because from Spark they fire queries the other way. That's more easy. You can start Spark SQL and say fire it. But Hive can actually use Spark as an execution engine. It is possible, right? And this is sub-second query retrieval via Hive LLAP. Only Hortonworks, LLAP. This is what I was talking about, LLAP. LLAP enables ACID transactions, faster queries, everything that you can think about a normal RDBMS. I mean, within few. But that again requires resources. I mean, even though it says very fast, it will take a lot of resources actually. So when you are running Taze itself is in memory. So anything which is in memory requires resources. In memory means RAM. It will use only RAM. So Taze itself is fast because of in memory. So your cluster needs to have a lot of RAM for LLAP and all. Otherwise it will be very slow. Procedure. So that is HPL, SQL is nothing. That is a combination. That's called Hive query language, HQL only. You can write your own custom functions and all inside Hive. Hive supports something called UDF, user defined function. You can write, so that is, they say it as HPL SQL as a fancy way of saying that only, right? I would feel vice versa. In the sense, yeah, see, if you are good in Java, MapReduce is your choice, but MapReduce is extinct, right? Then you go to Spark. Spark uses Java, but that is Java 8, functional Java, not Java 7. So a lot of people have trouble there. But even in Spark community, the most trusted preferred is Python and Scala. Then only Java comes. So Java is supported in Spark 100%, but developers are very less. People want either Python or Scala because it's easy to write actually, right? I would say some knowledge on SQL or Hive is very important, whatever you are doing, right? I will tell you this in Spark. In Spark, if you write your code using Python and SQL, the SQL is much more optimized. Because if I am writing anything using SQL, I have something called schema, right? Which means I can understand my data. What is schema? If I have schema, I can understand my data. So if I write a join and filter, I can push the filter first, then do a join. Are you able to understand? In SQL, I write a query. By default, it does, right? By default in SQL, if you write a group by, join, then filter, what will happen? Filter will come first. Because why should you load all the data, then finally you do a filter? First you filter, then do it. That's called optimization. That is not possible if you write a language. In Spark, we will see when we write Spark code, it is not optimized because Spark is not having a very tight schema. But Spark SQL has. So that's what I'm saying. SQL always has a preference because of its optimization. That is not possible in other languages. Like even in MapReduce you write, you have no idea how is the data underlying, right? You are not mentioning any schema. It has to load the full data to do analysis. Any MapReduce program you write, the whole file need to be loaded. You cannot say that select only this column and analyze. Not possible, right? First everything has to be loaded. So always the structured languages are having a preference on this. Java is good. I am not saying Java is bad, but I won't consider it in the further. Scala, probably you can relate with Scala. Scala is very similar to Java. If you know Java, Scala you can very easily learn. Scala with Spark is a good combination. Very good combination. What else you have? Questions? We'll wind up in 5 minutes after your questions. So tomorrow I'll be covering something called partitioning, bucketing, indexing in Hive, which are a bit advanced topics actually, okay, but very much needed actually to understand what is Hive, because they are the highlights of Hive. If somebody want to learn Hive, these are the points, or if somebody asks you about Hive, these are what they ask. Nobody will ask how do you do a select star query, right? That nobody is going to ask. They will ask how do you partition your data. So at least if you can understand the logic of it, that will be more than sufficient, right? And we will look at this NASA data. You have a NASA data, see, NASA. So tomorrow we will analyze NASA data using Hive. So I can show you the SERDI there, regex and SERDIs and all I can explain in this NASA data. So make sure these data sets are there with you. Anything else? Let me know. If you look at this case study that we have prepared. So this is about the NASA data, analyzing the NASA web server logs with Apache Hive. And this will be helpful because we will see the same data in Spark. In the Spark class also, this data will be there, same data. So if you understand the data now, we can analyze it using Spark as well. So I guess you are aware of this. Server logs contain lots of information from web servers, right? And this case study will show you how to derive insights from web server logs. So you are going to look at some log files which are generated by web server, and if you have ever worked with web servers, so let's say you type google.com and then download something, all these requests will be hitting the web server. So you will get request, put request, then HTTP status code. So that is how your log files will look like. Okay, I will show you the log file, and you can actually download the data for free from this URL. We have already downloaded and uploaded the data. You don't have to worry, but you can, it's public data from NASA. And if I scroll down, look at here. Before moving to the activity, please go through the HTTP response codes at this link, right? So are you aware of something called HTTP response codes? Yeah. If not, you can just go through this URL. So for every request there will be a code associated, right? So if you are browsing and hitting a web server, the server will respond with a code. So if it is 200, it is okay. Anything starting with 2 is success. 201 is created, 202 is accepted, 204 is no content and all. 30 is redirection. That website will redirect you to some other place, right? And client errors are 400 and 500 is server error. So sometimes you try to open a website and you will say 501 server not found or like that. So anything starting with 5 is internal server error, right? So gateway timeout, service unavailable, something like that you can see. So if you want, you can just go through this list, right? And understanding the data. So the data set contains 2 months worth of all HTTP requests to the NASA Kennedy Space Center server in Florida. So this data is collected from the NASA web server, and 2 months worth all the requests are there, and I think around 1 million lines are there in the data. It's pretty huge data actually, somewhere around 1 million lines. The log files are stored in the Apache common log format. So that's what a lot of people ask me, when you say text file, it is not with a .txt extension. Normally you say text file, that is something with .txt, but there are a lot of other data which is called text file. It is always not mandatory that you will have a .txt extension, right? So this Apache common log format, it is a text file, but you cannot open it in Notepad, right? You can open it in WordPad or any other thing and it will show you properly like text data. I'll show you the data, and now let's look at the data. So if I go here, there is NASA access logs, and this is the data. I'll say open with, I'll say WordPad, say OK. So this is how the data looks like, and it's not really pretty. I mean, in the sense like it's not really nice, it's not structured. And what are the fields we are interested in this, right? So this is log file, and if you look at here, the PDF, right? We have the host, identity, user identity, time, request, status, size. If I scroll down, the first field is the host making the request. Okay, so where is the host making the request? This is the host, this guy, in24.inet something. So this is the fully qualified domain name or the host name, host making the request. Then what we have, next two are the user identity from remote and local machine. These are unavailable. So next two fields are not used, they are dashes, that's fine. And then we have the timestamp in day, month, hour, so year, this format. So here you can see this. So this is your timestamp, right? The time when it is making the request. time zone. So this minus 400 is your time zone. What you see here is the time zone. Okay, and then there is the request sent to the server. So here you can see get, it's a get request. Okay, and somebody is trying to get shuttle mission status news, some news, something. Okay, so that's a get request we have. And then there is an HTTP reply code. HTTP reply code is 200. It's a success. Okay, and then you have the size of the file received. So probably in bytes 1839. So this is the data. So you can see that a lot of people are sending requests to the NASA web server, and that's how the data looks like. Now what we want to do, we want to create a Hive table to load this data, and then we want to write some queries. And the size of this file is 167 megabytes. So it's a big file actually, not very small. And we will test now how the cluster will behave, because if you start writing the query, all of us write the query, we'll see how efficient the cluster is anyway, right? And so the next question is that how do I actually load this data into Hive, because this data does not have any structure. To do that, we are using the SERD or the serializer, deserializer. Now a little bit information to you. I also want you to give you an assignment. So if you simply go to Hive and say SERD, yeah, you can see here. This is called a SERD. So what is a SERD? SERD is a short for serializer, deserializer. Like I said, if you are having data which is not really structured, like this log file or JSON files or anything, you want to read and write, you can use this parser called SERD, right? And Hive supports a lot of built-in SERDs. So these are the built-in SERDs we have, and we are going to use this guy, regex. You are aware of regex? Regular expression, right? So that means you can write a regular expression. Hive will parse it, and using this SERD it will read it. There is an ORC, SERD, Avro, these things we'll look at later. And then custom SERDs. You can write your own SERDs if you want, that's also possible, right? We will look at this later. Let's open this regex SERD. Yeah, so it says if you want to create a table and use the SERD, you have to say row format SERD. Remember previously we used to say row format delimited fields. Now I say row format SERD, and then I will say this is the SERD. Okay, and then you say with SERD properties, and you will say input regular expression. Whatever regular expression you have to put there, and that should actually be able to get the data, whatever regex you are writing, and then it should give the structure to the data. This is the idea, right? And this is very important, stored as text file. I think yesterday I didn't discuss it. When you create a Hive table, by default this option is there called stored as text file, which means whatever data you are loading into the Hive table, it will store it as a text file, regular text file, be it a CSV file or any file. So yesterday we loaded some customer data, transaction data, and they were getting loaded as it is. Okay. Now you have other options. You can say stored as ORC, Parquet and all. That is where the improvement comes, and I will talk about it. What is the difference in when you say text file or when you say ORC file? Where is the difference? But as of now we will say it is stored as text file. We are not bothered. It is by default text file. So that is why yesterday we were not mentioning it. It is by default text file. Now the data set is available in this location. Can you see here? /GL data and one moment, what was the name? Access, right? Yeah, so this is the file. It's called access. There is no extension, and it is available in a common folder called GL data. So first let's do one thing. Let's start Hive. Anyway, we need to start Hive. So start Hive. And let's create a table. So we will use the DB yesterday we created. I'll say use May 19, that was the DB, right. So you can switch to whichever DB you created, and this is the command to create the table. You can copy paste this from the PDF, okay, say copy, and I'll explain what it is. So you will say create a table if not exist NASA log, and the fields we are interested are host, identity, user identity, time, request, status, size, and then you will say raw format serd. We want to use the regex serd. With serd properties you can input the regular expression. So this is the regular expression we are using, and in the output we will just say that so that's part of serd. You will say that store it with equal spaces, right, and then you say stored as text file. So this is where you are saying that store it as text file. So this is your regular expression. You can go to the PDF, and if you cannot copy like this, right click, say select tool. There is a select tool. Once you select it, you can left click and copy like this. So you have to have some idea about regular expressions if you want to write it from scratch, but that's okay. Yeah, sure. I'll show you from console. Yeah, this is the command. I just said Hive, then use the database, and then just copy pasted the table creation command. Right now we have not loaded the data. You don't have to load the data. That output format string, it is simply saying that there are 8 columns, right, and with space, each column with space. It's a bit difficult to explain. It actually reads and separates all the data with how many spaces you have, and it is looking at digits and strings and then extracting the interesting fields. It's a bit difficult to explain the regex actually. So if you are writing a regex from scratch, you have to validate it. So this was validated. Even I don't remember how I validated. I wrote it long back actually. Yeah, so it's a create table. Yeah, normal table. Only difference here is that in the table properties you are saying that whatever data that comes to this table, apply the serd, the regular expression. Otherwise, it cannot recognize the data inside, right? So right now this is the Apache common log format, right? And Apache common log format has a fixed schema, not schema, the way the log files are generated. So you can write it in multiple ways. This is one way of writing it. So in Hive, if you look, they will simply say that this is the regex we want. Here I'll show you. So here it is a input regex. See, the output regex is not stored. So here you can see the input regex, right? Are you looking here? I mean, this was written like if you avoid the output string also it will work, but we are just ensuring that everything looks string. I mean, just we are manually saying that it is string, that's all. I think it is not updated. Hive's documentation is not updated. No, it is not updated. Let me see. So where is it? More about regex serd can be found here. So they have given 2 links actually. Probably it is here. Let me just check. So what happens is, let me just see if I can find it first. See, in open source communities, what happens is that, let's say you are looking at Hive or Spark or anything, somebody will create the product. So let's say I created Hive and I will give it to everybody. Everybody will start working, and then what will happen? Somebody will say that something is broken. So I may not add it in my documentation. I'll add it in a Jira. Jira is your issue tracking, right? It's a Jira link. In Jira link, it clearly says that there is input regex and output format string you should use. So somebody added a, yes, I will work on adding a serd how to and some examples to new directory. So somebody said that this is not properly formatted. So in the Jira it is added actually, it is not an official documentation. Originally when they created, probably that property is not there, I am saying, then somebody could have complained, but they have mentioned the link here, right? You can see that it is here. If you look at here, it says more about can be found here. I don't know why they are not updating the documentation, but it is there anyway. So one problem is this, if you want to search documentation, you may not find everything in the official documentation sometimes. So I always look at Jira, because any issues they fix will be in Jira. And also not everything, not every time things will not work the way you are expecting. So you have to Google saying that Hive plus Jira not able to read this file, some issue you are coming across, and there will be a Jira ticket for that always, right? So once now you have to load the data, so let's continue with that. And where is the location? The location is here, GL data, right? So how do you load? You say load data. Wait. If I do a load data in path, what will happen? I say load data in path, what is going to happen? We can create an external table, right? That's better. I didn't think about it, because normally the participants will have the data in other classes and they will upload themselves. So what do you want? You want to create an external table, everybody, and point to the data. That will do. Okay, so then you have to modify this. So how do you modify this? If you want an external table, you will say create external table. Let's drop the original table, okay? Do a drop. First do a drop table. What is the name? NASA log. So drop it. And now we say create external table, NASA log. These are all fine, and the only difference is location / GL data. Wait. External table, if you are creating, it should point to a folder. This will load everything from GL data. We don't want that, right? In GL data, you have lot of folders, right? So I will move it. I'll see if I can create a folder in GL data. Let's see. New directory. I call it as NASA. Yeah, and I'll move it inside here, right? That should make sense. See, you have to take care of everything. Not this, right? This one, right? Access, action, move to GL data, NASA, right? There is no NASA folder. Yeah, there is. Move. Fine. So ideally, now if I check NASA, it should be here. Now it should work. Otherwise, it will load every file from the GL data folder. We don't want that, right? So what should be your location? This should be the location, right? And let me see if it works. No, you can use small letter or capital letter. So the table creation will work, I know that. My question is, what about the query? Select star from works. So you have to try this and let me know. It works, but all of us are accessing the same data, okay? All of us are in the same data. So make sure you can see properly structured. Now I already created a table first, right? And I dropped it because how do you load data to that table? We have a shared location. So it is better to create an external table to point there. So I dropped it and recreated the table. So here it is location. And also here is a location. This also should be there. This external you can type small letter or capital letter. Folder name should be case sensitive, I think. and do a select star and let me know whether you are able to see the data. So there are two approaches. Not every data can be made structured also. There is one problem. So Hive is a structured tool. That means somehow you should give structure, then only it will work. There are some type of data, like for example, there is a format called Avro, AVRO. So previously when you get Avro data, because that's like unstructured, you are not able to do anything. But now there is an Avro reader they have created. So there are still some type of data where you cannot give a structure. One point. Second point, how this works in organizations is that, like I said, there will be a data ingestion team, right? So I'm just giving you the example of GE. In GE what happens, see, GE's business is so enormous that nobody has any clue what is happening there. GE is one of the biggest firms in the world actually, right? And their size of data is enormous, what they are getting. So they have financial applications, okay? These financial applications will generate data, okay? And how do you get the data? They will have APIs, they will pull the data in JSON format. So it comes in JSON format. And sensor data they get, sensor data. So they have this locomotive engines, train engines in Europe, GE has created. So these train engines, whenever they are running, will produce sensor data. They collect it and that data will come through Kafka. It will come in a Avro format through Kafka to Hadoop. Ultimately land on Hadoop, but the data is sensor data. So it's like events. Sensor data will come in events format. Like whenever there is an event, it will generate a data. It's text file only, but the format that they get is called Avro. So the point is that data, when it lands on Hadoop, nobody can give any structure to that data. Nobody on earth can give. So GE has a data ingestion team. Their job is to take the data, give some structure and give to the big data team. You are getting my point, right? Because if you directly give it to big data team, they have no clue what to do with the data. So there will be a staging area where all this data lands, okay? And they had written some Java code, custom Java code. What that Java code will do, it will read the Avro, remove some unwanted fields, give some structure, send it to next side. So that is how they are injecting the data, I am saying. So raw data, most of the times you may not be able to directly handle it. And second use case is, if you are a big data developer or like us, we don't want data in the original format. But if you are a machine learning guy, you want the data in original format. Are you getting the difference? Like if I am a data scientist, I don't want anybody to touch my data. I want the original data with all the nonsense. Then only I can build my machine learning models, because they want all the features. They don't want to modify the data. But if I am a big data guy like this, I am happy with structure. I can lose some data. I just need the structured format. I will work. So these two teams will be there. So the machine learning teams will be original data they will be collecting, and then they will have their own algorithms to crunch the data. Kafka is used because their data is coming from Europe. Streaming data. They don't stream live, they stream once in a day or something. I mean, they collect all the sensor data. It's in Amazon. The entire setup is in Amazon. So there is some sensor which in Amazon you have a solution, right? Who is working on Amazon? Sensor data, you have a solution in Amazon. What do you call it? Kinesis. Kinesis, right? Kinesis is your sensor platform in Amazon. So Kinesis will collect all this data, and from Kinesis it will push to Kafka. Because somewhere it has to store, right, the data. There are very less real-time decisions they want to do on that data, because there is train data, and only time when they are analyzing that data is if the train is not working, like it crashed, the train engine got crashed. Otherwise they don't want to analyze it in real time. 99% of the time the trains are running. So this data is useless for them. So when the train engine got crashed or something happened, that time they want to look at the data last 24 hours. What caused the crash? So they are not doing, because the size of the data is in petabytes. So analyzing it is also not possible for them. So they collect it real time and batch it and send it once in a day or something. And it will go through Amazon, it will land in Kafka. Why Kafka? Because from Kafka 2-3 teams will collect it. One team is using the data for something else, distribute it, and then one copy will be stored in Hadoop. like original data copy. Anybody want, they can get it. That is how their architecture is right now. GEs is an evolving architecture. They are just moving to Hadoop now. It's not a stable architecture. So probably after a couple of years they'll find another way to better this things and all. Right now they are not doing real time on the this train data. They also have flight data. Flight. This aircraft engines are all GE, right? Commercial aircraft, all are GE, 80%. And all these engines generate same sensor data, they collect it. But again, that's all not real time. It's very rare you get a problem, and that time only they want to analyze. So I hope you are able to reach here, right, till this point. So this is the place where your data is there, right? If you go to this location, I have copied the data there. Now if you look at the PDF, what it says, load the data, select star. Now these are some of the use cases I wrote. I mean, you can also write your own use cases. So find the top endpoints that received server side error, meaning which are the how many endpoints have received server side error, right? I'm just asking, like, there is 501, 500, these are all server side error, and how many times it has occurred. So how do you figure it out? There are multiple ways to do it, but one of the ways is this. You can say select status count of requests from the what you say NASA log table, group by status, and you can say having status regular expression extract. So here I am saying that anything starting with 50 in the status column, because 50 is server side error. Order by status descending limit 5. So that's the query. So I just want to know all the errors starting with 50 and count them, how many are there. Right? That's what I'm writing. Now when you are using having, it has to be double operator assignment. In having close, in Hive, when you are using having close, it has to be assignment something. If you say equal to something, it will become a equal to 1, it will become a become 1. So here I am just saying, just comparing, that comparison operator is double equal. No, in having only I am saying. Where close and all, it will be normal. In having you will say, so somewhere there was a documentation on this, I will share it with you. Okay. Can you try this query and see, now it is taking time, 24 seconds only for the first. Anyway, this will take some time. Can you guys try the query? It will be slow. So when you mention the commands, it has to be either full small letters or full capital letters. He said capital L location, and it's a bug. I know this because otherwise it should throw an error. It won't throw an error, and this is a very common thing. If you create external tables, you mention location, even if that location does not exist, it may not throw error. And you will try querying, nothing will come up, you will think, what is the problem? Now space is fine, but ideally this location keyword, sometimes it has a problem. So that is what I did, it started working, but you are getting. Or maybe that itself is not a problem, I dropped it and recreated, probably it started working, not sure. So how much time it is taking for you to run the query? 75 seconds. There is also one more point which I forgot. Yeah, so anyway, so somebody was asking about this reference on regular expression. Here you have a Hive language manual, it is in the PDF. And which resource is requested most frequently by the host? This is a good question, right? Because which page is requested the most? And I don't think it's a very difficult query, but still we'll run it just to see. So now if you look at here, it says select request comma count as request count from NASA log, group by request, order by descending limit 30. You are looking at the top 30 requests actually, right? You can skip header and all, but I don't think you can skip the data part. I don't think you can skip columns. No. I don't think you can filter, because ultimately it's on Hadoop. So the data remains on Hadoop, right? So that's one problem, because if it is in HDFS, then there is no way you can filter anyway. Locally I have to see whether he is asking, while loading the data, can I filter the data? Like, I don't want all the 10 columns, I want only, you have skip header, that option is there, table properties. By the way, there is something called table properties. If you just go to Google, say Hive create table TBL properties. So in creation of the table, there is something called table properties. Where is it? So table properties, right? So here you can mention the skip header and all. Let me just check. No auto compaction, mapper memory, auto purge, external true. You have skip header is there, that's for sure. But I don't think you can skip other columns. That is not possible, I think. Anyway, I will just see if I can get back to you on that. Okay. And there are some more queries I have written. You can try that, like display the top 10 hosts who made maximum request and all. You can try that. Find the total count of different response codes returned by the server. So just try these queries. Let me know if they are not working. I have not actually tried everything. It should work. Okay. So now talking about Impala a little bit, right? Probably not in depth, but you should know a little bit of Impala because it is heavily used in industry. Impala. If it is in the Cloudera side, we are on Cloudera side. If it is Hortonworks side, everything is Hive, but in the Cloudera side, we have something called Impala, right? So a small intro, not much, but and I will show you an Impala query also. So what is going to happen? If you are having data nodes, right? So this is a data node, this is another one, and this is another one. You can install something called Impala, right? And if you are using a Cloudera distribution, Impala will be by default installed. You don't have to worry. And Impala is its own SQL engine. It does not depend on Hive or anything, right? So when you install Impala, what will happen? There is a daemon called Impala D. Impala D. It's called Impala daemon. It will start running on every data node. Like something like Oracle. I mean, I'm just saying, right? So this Impala D will be running on all the nodes, first of all, right? And Impala has a shell from where you can fire the query. It does not depend on Hive. And if you fire a query, what is going to happen is that, let's say it hits this machine. So the query will be accepted by one of the machine. So let's say this guy, right? And this guy will look at the query. Now Impala can talk to Hive's metastore, which means whatever tables you are creating in Hive, Impala can see. So all the tables you create, you can query using Impala. So, and whatever tables you create in Impala, Hive can also see because they share the same metastore. So that is one advantage. So, and on top of that, another thing is that when you write a Hive query, it will convert that into MapReduce. So Hive is not bothered about how the query is running, because it is the responsibility of MapReduce to run the query. Impala will not convert to MapReduce. Impala has this Impala daemon which will run the query for you. It is like a RDBMS, I can say, not an RDBMS. I am saying, like if you are firing a Oracle query, who will run the query? Oracle will run the query. Same like that, if I fire the query, this Impala will get the query, and it is the responsibility of this Impala daemons to execute the query. So they will have the Hive metadata. Okay. They will also have the block metadata, meaning if you create an Impala table like a Hive table and you say load the data, right? Now the data is actually in Hadoop and the data is in blocks and replicas. Now who has the metadata about this? Name node. These guys will copy that to themselves because they should know where is the data. Impala is not going to depend on anything to fire the query, it will run itself, right? So that is why the queries are very fast, and when the query hits Impala, it runs in memory. So there is a drawback. So let's say the data was here, you have a block here, you have a block here. What will happen? You will have RAM, this block data will come here and this block data will come here, RAM, and this guy will simply coordinate the query because the data is here and here, right? So this guy will coordinate the query and it will run the query in memory. The drawback is, if let's say this machine crashes, the entire query will be aborted. It is not fault tolerant. But Hive queries are fault tolerant because MapReduce is fault tolerant. There is no way MapReduce can fail, right? But Impala queries are not fault tolerant. So if the one of the machine, because it is a distributed query, not one machine is running the query, probably 10 machines are running the query, and if any one of the machine crashes, the query will be aborted. But it will not convert to MapReduce or do anything, so your queries are super fast actually. Directly hit HDFS, query the data and give you the output, whatever you want. So it's faster, but this reliability issue is there with Impala. So what we do, if you are having a Cloudera cluster, if you are having ETL jobs, we never use Impala, because in ETL jobs, behind the scenes it will be running Hive query, and probably the query will take 3 hours to run, 4 hours to run, probably 5 hours. That's fine. Even if during that ETL job a machine crashes, I'm safe because it's a Hive query, my MapReduce will take care of it. But if I run that ETL query using Impala, let's say the query will be faster, 2 hours probably it will take, but after 1 hour if one of the machine crashes, my Impala has to restart the whole query. It will throw error, but again your ETL job has to start from beginning. You lost 1 hour, right? So actually it needs Hive's metastore. For the metadata, Impala must use Hive's metastore. So Hive should be installed. So that is another advantage. Hive will remain because lot of tools requires Hive, even Spark SQL. Spark SQL, normally when you configure Spark, you will tell Spark SQL use Hive's metastore, so that Hive's metastore is used by everybody. So all the tables you create, all will be in one place, right? And if the table is there, you can either query using Hive, query using Impala, that's up to you to decide. But Impala also has some drawbacks. This NASA table we created, you can't query using Impala. It is, this regex is not supported. So this table is created using regex srd, that is only for Hive. I can see this table in Impala, but I won't be able to query, I think, if my memory serves me well. But most of the regular tables you can query without any problem. Both of them can access at the same time because metastore is a shared place. What is metastore? It is your MySQL. It's a shared place. Anybody can access. Not only Hive and Impala, hundreds of other people access. It need not run. You have to install Hive and set up a metastore. I am saying whatever table you create in Impala, it stores in Hive's metastore. So each data node will have an Impala daemon, and each daemon will have a copy of Hive's metastore block data. So, and what happens if you fire a query, any daemon can pick it up. That's called a coordinator. Meaning, if I write a Impala query, there are hundreds of data nodes. So, any data node running Impala can get the query, and that node is called a coordinator for that query. So, in this example, this is the coordinator because this guy accepted the query, but this does not have the data. That's fine. Okay, and once it gets the query, it does a local lookup. So, it's very fast. It has the metadata. It understands immediately here is the data, here is the data. It just splits the query and streams to here and here. These guys run the query, collect the result, display to you. So, ideally a lot of machines will be there where you are having data, but the metadata lookup is very, very fast. There is no frequency, you have to manually refresh it. It will not automatically copy, meaning if I create a Hive table, it will not appear in Impala. I have to refresh the metadata. There is an option in Impala where you can say refresh. So, if you feel that there is some new table, you say refresh, then only the metadata will come. A block metadata, so that will come once your table metadata is created. Say I am creating a table. Once I create a table, I load the data. Then only the metadata of that data will come. It will not store the whole Hadoop metadata. Your Hadoop cluster has, let's say, 1000 terabyte file. Okay, Impala will not store 1000 terabyte metadata. That is useless, right? You are saying this Hadoop cluster has, let's say, 1000 files. Okay, in which you created an Impala table. Okay, you say Impala table, you loaded file 1. It will have the metadata of only this file. Why should it need all the metadata? The query will hit only this file, right? Only related to that table I am saying. When you create a table, you will say load the data. What data? So, in our example, we loaded the NASA data. So, the block information of that NASA file it will remember. From Hive, or if you are directly loading into it, it will remember itself. It won't remember the block information of other files. In Hadoop, you have a lot of files, right? Not all the files are in table. Are you getting my point what I am saying? It will remember only the metadata of the files associated with the table. Otherwise, why it should remember all the files? Manual refreshment is required. I mean, block it may remember. I am saying the table properties, it will not automatically refresh. So, you have to manually refresh every time. So, usually we won't do like that. Usually, even though Impala and Hive can communicate, we don't do it. Because Hive has its functionality, Impala has its functionality. Meaning, whatever tables you have in Hive normally, they will be used for reliability like ETL jobs and all, and that Hive will handle. Impala will, you will create separate tables, you will say do the same thing, load data, local in path, blah blah blah, and that will be handled by Impala only, like separate tables. They can talk to each other, but what I am saying, if you want up to date information, you should say refresh, then only you can get it. And there are 2-3 types of refresh, I don't remember completely. There is a complete refresh which will redo and load the total metadata from Hive's metastore, blocks, everything. There is a partial refresh. You can do it in Hive. So, these things are available in Hive. I am not just saying that, I mean you will be wondering. So, if you go to query editors, you can see Impala, right? So, here is Impala. So, probably the table you created right now should come in Impala. That is the logic, right? So, if you go back, where is the May 17, May 19, this is my table, my DB, right? See customer, NASA log, these are in Impala. And if I do a select star from NASA log, I don't think you can see it. I doubt. 5, I doubt you will be able to see it. Maybe, I don't remember exactly. No. Failed to load metadata. Failed to load metadata, invalid storage description. Impala does not support this table type. Reason, SERD library not supported. It won't support that SERD. That's why you are not able to see that. No, it won't. That's what I'm saying. Impala tables, if Impala is querying your data, it's not fault tolerant. So what the ETL will do? It will query and get the data. Who will query? That's the question. If Hive is querying, it is fault tolerant. So here you can see the NASA log thing is not supported, but if I look at any other table, so let's say select count star from, let's say, out 1, right? If I do this, ideally it should work. For some reason Impala is a bit slow in this. Hive is faster in this case. It is not really like this actually. It's very fast. Yeah. There is no MapReduce. It directly hits and gives a result. The same query if you run, you will see MapReduce job starting, MapReduce, nothing. So we will, and there is one more thing. This refresh manually has to do. Normally we do it manually. You can write a batch job to refresh. So I don't know whether the refresh is actually configured here or not for the Impala, because this NASA log table is available. We just created it right now, but it is available in Impala. So probably, and this is the option to refresh. Can you see this refresh? 3 options will come: clear cache, perform incremental metadata update. This will sync missing tables in Hive, which means if you have a new table in Hive that is not here, it will do it. And then there is invalidate all metadata and rebuild it. This can be both resource and time intensive. When you say invalidate, it will delete the whole metadata and from scratch it will build. That will take a lot of time. So these are the refresh options in Impala that you have. So try to create a table, see whether you can find it in Impala. I don't know. So we'll create some simple table, right? Which table you want to create? Maybe I'll just change this and run it as it is, right? So I just created, and if I go to Impala, May 19th, where is it? No, I don't have it. So if I say refresh, let's say perform incremental refresh. Now it came transaction record. So ideally we do this manually, because Impala cannot automatically identify you created a table in Hive. If you do it, it will come ideally. So Impala also stores a lot of metadata and actual data. Recent queries are all in the cache. So if you want to clear it, you can say clear cache. The recent queries you ran, it will store it in the cache. It will store. So sometimes the cache will become big, like you are running a lot of queries. So that will affect the performance. So you can simply say clear the cache. Yeah, ideally it should keep it in the cache. Hive does not use Impala. Hive uses only MapReduce. No, I don't think that is possible. Probably admin or somebody can do it. From a developer side, I have never, I mean, what is the use case? I don't know. I mean, masking, table masking is there. I don't know if it is possible. I have never tried. So table masking you can do. So that has to be done by the admins. So you can say that mask the table. It will not be visible to any other process like Impala or Spark or anything if you want. But usually we won't do like that. Usually we restrict the access based on user. So the user, so if I am a guy, okay, so all the Hive tables will be there in Impala, let's say. But if I am a guy who is a developer, and my access will be that I can see only these tables in Hive or these tables in Impala. So behind the scenes everywhere you will have tables, but user level access you can control, who can see what tables. Otherwise everybody will be able to see all the tables, right? I don't think directly there is an option to stop them communicating. Hortonworks Hadoop does not have Impala. They have this thing. Hive is there, and by default Hive plus Thais is the execution engine. Then LLAP. LLAP is their highlight actually. LLAP is much reliable, much faster than Impala, to be honest, right? So I'll show you LLAP, maybe not now, I'll see a session. So this part is clear, right? Hive and Hive plus Impala, I mean at least basics. Hue has an automatic way of identifying the data, but that will work only if you have a proper delimiter. like comma or space. In Hue you can create a table. There it will identify if you have space or comma or something. I don't think geospatial data means what is the structure. So Impala, I mean this much only you need to know as of now. I mean I'm just giving it as an option. Normally in Hive classes we don't teach Impala at all. The sense why Hive is Hive, Impala is Impala. Not subject, like it has become like, so people don't learn it separately in the projects because the queries and all are same. The SQL you write, everything is same, there is no difference at all. Only thing is the use case is slightly different. No, only it has its own, and it is contributed by Cloudera. Impala is an open source project, but mostly the contribution is from Cloudera, so it is like a proprietary product. So if any issues comes, Cloudera will support a lot in Impala, point number one. And so another problem is that if you go to other platforms, you won't see Impala. Probably that is the reason people don't care much about Impala, right? So if I go to Hortonworks, I will not see Impala at all, right? If you want security, there is something called Sentry service. Sentry, you have to set up Sentry. I don't think we have Sentry here. So in Cloudera, I'm saying in Cloudera you have something called Sentry. Sentry Cloudera. So this is called Sentry. Here you can set up all the user level access, service level access, everything. Sentry, again Sentry is open source, but so here you have users, groups and access. See, authorization privileges model for Hive and Impala. So the problem is Sentry is again Apache, but only Cloudera uses. You go to Hortonworks, you have Nox and Ranger, two tools. One is called Ranger and Nox. Again they are open source, but only on Hortonworks. So one problem is that platform wise there are some slight differences. I mean it happens. So there are slight differences. Cloudera uses this Sentry, and in Sentry you can configure who should access which table and all the authorizations the admin has to set. I don't think Sentry is installed in our cluster, which means anybody can see anything. Even Hive, for Hive you have authentication. Username, password you will create. Here that is not there. I mean as of now we are just saying Hive, it will enter, right? Kerberos is by default. I am saying right now what you are doing, you are logging into one of the machine in the cluster. It doesn't work like that. Are you getting my point? So I think we discussed this in the first class. So this is your cloud lab, right? This is your cloud lab, and you have an edge node. So you log on here, from here you connect to the lab, and any security, any service you need, you have to enable here. And as of now nothing is enabled, so when you just start Hive, you just hit the cluster and anybody can see anybody's table or anything that you create. Sentry is not enabled, I think, and that even when you're working you want to have access to Sentry and all. It's totally the admin side, they only can decide who should. You can request them, you may be not able to see who has access. Yes. So they will be in the cluster, but once you hit the edge node, that will be applied to you, like all the policies, whatever you are having. Otherwise you can't restrict the users, right, from coming in. Hortonworks has Ranger. Hortonworks. Ranger is similar. I also like the Hortonworks documentation a lot. It is much more precise and clear. You read, you will understand what they are talking. Cloudera documentation is very weird. Nobody will understand what they mean. Look at Hortonworks on documentation. It's very easy to read and understand. See, comprehensive security for enterprise Hadoop. What Ranger does, how Ranger works, right? Everything you have here. So Apache Ranger offers centralized security for all these things. Hive, HV. So if you go to Hive, they will show you what Hive does. See, there is even a YouTube presentation. Very nice documentation they have. The best documentation actually Hortonworks. See, LLAP, Live long and process is what I said. I think there is another explanation. It's not actually live long and process. Something else is there. Hortonworks just say it is live long and process. I don't think it is live long and process. So Hive details are here and some optimization techniques are here. Okay. Hortonworks document is the best if you want to learn. Only thing, if you are in a Cloudera production cluster, some of the things may not be applicable since it is totally open source. Like they have their own ways, right? So if you are using a Cloudera cluster in production, you should always refer Cloudera documentation, because not everything will be same. Some difference will be there, right? I hope that clarifies Impala. So we are talking about Impala. Now I have to talk about something called partitioning in Hive. Okay. So how many of you are actually aware of partitioning? Some of you might be aware of this concept. Yeah, for those who are already know this, probably it's a refresher, right? See, the idea is very simple. So can you tell me, so your manager asked you to create a sales table, okay? And you are creating a DB called retail and a table called sales. So where will be the location? Let's say manage table. It will be user, Hive, then what? Warehouse, and the DB is what? Retail, and the table is what? Sales. This is the location, right? For the manage table. And let's imagine every month you are getting the data, month end. So in January you got the data, so it became what? jan.csv. You said load data local, blah blah blah. This is where the data will go. You know this already. And the data got uploaded here. Everybody is happy, no problem. The problem is, as the next month and next month happens, right? What is going to happen in your sales folder? In February, what will happen? February data will get uploaded. It's in the same folder, by the way. And again, what will happen? March, right? And April and May and so on. So the problem is, if this is the model you are following, after let's say a couple of years, if you look at the folder, you will have 10-20 files inside the same folder. Now the real problem is, let's say you are writing a query, something like this. Select star from sales, right? Where let's say month equal to Feb. Let's say you are writing this query. The problem is, Hive has no clue where is your data. It has to scan all the files in this folder to give you the result. The result is here, that you know. Hive doesn't know. When you write a query, it will scan all the folders in the sales folder. So if you are having, let's say 100 files, Hive has to scan all the 100 files before producing the result. The drawback of this is that your queries will be very, very slow. So in order to avoid this problem, if this is the problem you are facing, you can do something called partitioning. Partitioning of table. Okay. And in partitioning, you have two things. There is something called static partitioning and dynamic partitioning. Static and dynamic you have. Two type of partitioning you can do. Okay. And I will show you that with the help of an example. That will be better. But what is the idea? In partitioning, first you have to identify the column or columns. Based on that you want to do partitioning. So I am assuming that this is my table structure and most of my queries are based on month equal to something, right? So what I can do in Hive, I can say that, okay, create a partition table where the partition column is month. And what Hive will do, if you provide the data, it will automatically identify and create folders like this and will place the data like this. So when you partition based on month, Okay, there are multiple ways to do this. I will show you. Technically, what is happening behind the scenes is that it will identify the month column, and as many months you have, those many subfolders will be created, and it will move the data. Now we know that there are only 12 months in a year. So if this is the data model, you will first partition based on year, then month. So that it will create a folder called 2016, within that 12 subfolders. Then 2017, within that 12. So, but if this is the model, if you write this query, it will only hit here. It will skip all these other subfolders. So your queries will be naturally faster. This depends on what is the columns you are having. So let's say I am saying here the column name is Jan. So what is the next column? You have a week 1, week 2, like that you have. I mean, this depends on the data. Now in this data, I don't have date. I have a month column, I have a day column, I have a year column. Now partitioning is not a must. It's not like everybody should do partitioning. There are many conditions where you cannot do partitioning. So like you said, if you are having date, you can't partition directly, because if I have a date column and let's say you are looking at last 10-year data, how many dates will be there? 3650. If I say partition by date, it will create 3650 folders. That's useless. There is another way to tackle it, I'll tell you, but you don't do that. So partitioning is applicable if the cardinality is very less. Something called cardinality, right? How many unique values you have in the column. Like in this case, or let's say you are getting data from different countries in the world. Fine, maximum you have 150, I don't know. Country wise you can say partition. But yeah, like you said, or another case is that you are having transactions and I want to divide the data based on transaction ID. That's not possible because every transaction has a unique transaction ID. It starts creating those many partitions. That's not possible. So partitioning should be used only when your cardinality is within control, like this. Right now you are partitioning only on the Jan column. I am giving him a different use case. Let's say you are getting the data from different countries. It also depends on what query you are running. For example, let's say this is the partition data. I write a query, select star from sales where country equal to India. It is a worst query I can write because my data is partitioned on month and I write a query based on country. It will have no impact. It is actually worse. So if you know that most of your queries are based on country and month, you partition by country and month. I mean, whichever way it is possible, probably first partition by month, then country, or country, then month. You have to figure out the cardinality. So that, and also if you are ending up creating lot of partitions, that's not a good idea for Hadoop, because Hadoop does not like a lot of subfolders and subfiles, right? So, and another drawback, I think I discussed this in the first class. This partitioning, if you do in traditional databases, it is sometimes not effective. Why? Because we had a use case where we had a Oracle cluster like this. Now 4 machines are there. Okay, and then you are saying, let's say you are looking at the iPhone sales data. You are selling iPhone sales data, and you want to partition the data based on country, number of sales in which country, right? So I will say that partition by country, but that's a logical partitioning. You are not physically dividing the data. The problem is it will create countries like India, China, US and all, right? So probably US partition will be here, this much will be there, and probably what, this will be what, I don't know, give me some weird country, Congo. You are getting the problem? You are logically partitioning. You are saying that divide the data based on country. Since in US lot of people buy iPhone, what is going to happen? US partition will be very big. This will be your US partition, right? I am talking about Oracle, okay? And this will be your Congo partition. And in Oracle, if you fire a query, what will happen? The machine is responsible for, they won't work together. So the US partition queries will be very slow because this guy has to churn. The Congo partition will be very fast, right? In Hadoop also what happens, you will do the same partitioning, okay? You will say that you have US data, India data and all, it will create subfolders, but the advantage is that even though this file will be 3 TB, it will be on 100 machines, blocks. In Oracle, this will be one machine. Are you able to understand what I am saying? So if you are storing the data in Oracle, Oracle has no idea of blocks and replicas. So US partition data will be 3 TB, 3 TB will be one machine. It won't divide this. If this is in Hadoop, 3 TB will never be in one machine. Blocks will get divided, right? So my query will be faster actually. So the partitioning is much more effective in Hadoop, I am saying, right? So which means partitioning in traditional databases and all are not so effective. It is effective up to an extent, but you have to ensure all the partitions are having equal amount of data. So partitioning is logical in every case. Even in Hadoop it is logical, in Oracle it is logical. In Oracle, I am saying that all the partitions of US should be in one machine. There is no way I can further divide this data. You are getting my point, right? Because it is not Hadoop or something, it is just a DB. So all the US data will be in one machine. So that machine will have lot of data related to US. But in Hadoop, if these are 4 data nodes, you will never have 3 terabyte on one data node. It will always divide and spread. Are distributed. So my performance is better in partitioning, right? So these are some of the things we understand when we work, right? So that is why some of the companies will say don't do partitioning much. Sharding is there. Sharding is dividing a table, existing table. Sharding mostly we do in NoSQL. Oracle after 11G supports sharding, but it is not extensively useful actually. In NoSQL databases, you can do something called table sharding. Table sharding is like physical division. You take a table and say take 10,000 rows, just divide like 3 or 4 and then dump it, okay? But that is not highly possible in RDBMS, because in RDBMS you have normalization. It is physically, any partition will physically divide the data, but can you say that I want to divide this table into 2 GB, 2 GB, 2 GB? That's not possible, right? That is logical. Physical division means, like he is saying, sharding. I take a table, the table has say 1000 rows. I can say divide it into 5, 200, 200, 200 rows, keep in 5 machines. That's not possible, right? In normal RDBMS. That's called physical division. You are not giving any condition. You are saying take the full table, split it into 5, 100 rows, keep it in 5 machines. That's not possible, impossible in RDBMS. In NoSQL it is possible because it is denormalized. In NoSQL everything is denormalized. So I can divide my data and push it in whichever way I want. Nobody cares. It's already distributed. In Hive or traditional RDBMS, physical division is not possible. You logically divide. You say, look at this column, and if you have 100 values, divide into 100. 200, divide into 200. You don't have any control. You can't say this much division I want or this size I want. There is no physical control. Logically you are dividing the data, right? There is no way for it to understand. After March again there is a Feb. Hive has no clue, right? It keeps on searching all data. So creating this, either you can manually create these folders, or you can, so normally we don't do like that. We run a command and create it actually. So it is better to do this rather than talking about. This is just a basic idea. I want you to find out the data set and then start working on it. So there is partitioning. Can you see this folder? Partitioning. And there is a Word file if you want. I mean, this has the commands. But I have been facing one issue with this Word file, which is when you copy paste, sometimes the commands will not work. We will see whether it will work here. Okay, that quote, right? What you call single quote, it will not identify. So we will see whether it works or not. So we have not discussed what is static partitioning or dynamic partitioning, and I will talk about this. First thing, let's create a table and then we can start talking about it. So do you have the DB? Yes, right? Okay, the DB is here, and I will say create table. Just copy this command, okay? Now static partitioning is a bit confusing, but we can understand. So I am creating a table called user1. As you can see, if you look at the schema, it has first name, last name and ID, only 3 columns. And then I will say partitioned by country comma region. This means these are my partition columns. I want to divide first by country, then by region. Fine. But there is a catch here. What is the catch? What is the data you are going to load? If you look at the data, this is the data, user info 1. And if you open this data, can you tell me how many fields are there in this data? 3, which are first name, last name and ID, right? And if you look at the table I created, it is matching here, right? Then I am saying partition by country comma region, right? But there is no country or region here, right? This is static partitioning. So static partitioning means you are getting the data, you know from where the data is coming, but the data will not have that columns. Meaning I know that probably this data is coming from country equal to US, state equal to California, right? And while uploading this data, I should mention it. The data does not have any columns for country or region or anything, right? If I upload the data, you will understand. So do one thing, copy this to Hadoop, this user info 1, can you do it? Go to HDFS, there is, I'll just copy to Raghu, user info 1. In fact, copy all so that we can save time, right? I mean, these are also required. Yeah, so then you have to use FTP. If you are copying to local, you have to use FTP. Better copy to Hive, it's faster, right? Anything. And I have a question to you. So right now in Hadoop, will it be already created the country and the region folders? What do you think? So partitioning means it is creating subfolders, right? I am saying create a partition table, country and region. Will it actually create a subfolder? Yeah, so no, nothing will be created as of now. And then what you need to do is, where is the WordPad? So I will copy this because I don't want to type a lot, but you have to change it, okay? Don't type it as it is, because what is the location? Raghu for me. File name is different, I think. Userinfo 1.txt, right? Is there a txt extension? Yeah. So now what I'm saying that load the data, and this is my data, into the table, and while loading the data I'm mentioning the details. I'm saying there is a country New Zealand and region Quebec. So what will happen, it will create a folder called country New Zealand, another folder called region Quebec. Within that this file will go. Can you verify that in the warehouse folder? If you have loaded it, it should be available in the warehouse folder. So I'll go to Hive, I'll go to HDFS, and where is your data? User Hive, right? User Hive warehouse, mine is May. So many DBs are there. People started May 19 DB. Here is the user 1. Can you see country equal to New Zealand? There is a folder in Hadoop called country equal to New Zealand. Within that there is region equal to Quebec. Within that you have your data. Try yourself and see whether you can see it. This will be there in your project and assignments. So partitioning is very important. It's in the Word file, right? Oh, okay, so it's wrong, right? Sorry, I'll just show here. So remember this point, static partitioning should be used like we had a use case, okay, where we were getting user data from multiple countries, okay. One of our clients application, the user data was coming from multiple countries, but the data will not have a country column. So we used to manually create, that's called static. You will say that put this data in US. Now we have to do something called dynamic partitioning, and I will show you that. So make sure you are able to log into Hive, and always do use your DB. Some of you are using default DB and when you type the command it will say already the table exists because a lot of you are actually using default DB. So if you meanwhile if you look at this data, right, Hive partitioning, can you tell me what is the difference between this data and the previous one you loaded? Exactly, it has the city and state or whatever. By the way, what is Togo and West Bengal doing together? Whatever, okay, so you have some city or region. Yeah, so this data has the country and city column. So the best way to do partitioning here is you create a partition table. You say there is a partition by country and state or whatever column, and then you tell Hive, I'll give you the data, you decide yourself. I'm not going to divide the data. You look at the column, I understand how many countries are there or how many states are there, accordingly create them and put them. That is called dynamic. But it's only like 20 lines of data, 20 or 20. Those many will be created ideally. And I think the first part, it starts with Christmas Island. There is no repetition, right? But there is one thing you have to understand in dynamic partitioning. Dynamic partitioning is by default disabled in Hive because somebody can come and say that, okay, create a dynamic partition table, use transaction ID column. Then what will happen, millions of partitions will get created and it will screw everything. So by default, even in production clusters, dynamic partitioning will be disabled. So first you have to enable it, first thing. Second thing is that you cannot upload the data directly to dynamic partition table. What you need to do, first you upload the data to a temporary table or some table, okay. From that table you insert to partition table. Meaning previously what we used to do, we created a static partition table, then we said load data in part, it went. We are able to do that because we know which partition where it is going. Right now we don't know, Hive has to decide. So what I will be doing, I will create a table first, normal table, I will upload this data, no partitioning, nothing. Then I will create a partition table and from the original table I will say insert to the other table. So while doing that it will divide and send. That is the only way to do dynamic partitioning in Hive, okay. We will do that practically so you will understand. You can't directly load, it has to be in a table, from there you have to do insert. But in this example it's not really useful because you are having all unique values. Like normally you should have like 5 records for one country or something like that, but here everything is unique values we are having, but that's the idea. Let me see if I have another file, okay, because partitions in Hive, just this LAN property case study, one moment, okay, load list. I will do one thing. Once we finish this particular example on dynamic partitioning, we will do something called bucketing also, and once we finish that I will give you this assignment, this landed property analysis. You can do it by yourself. I mean, now it's easy, commands are already there, and that will help you to reinforce the idea on partitioning. This has partitioning also. Just try that once I finish, okay. So for the time being, for dynamic partitioning, what we will do, we will create a table called user2. You can see what I'm doing from here. Same thing, I copy paste. And this is the partitioning table, right? Look at here, I'm saying that partitioned by country and region. So this table is the one which will have my data partitioned. Okay, then what I do, I'll create a table called user3. That's a regular table. First name, last name, country, region. First name, last name, country, region, right? So do we have only 4 columns? Where is the data? User info 3, right? No, we have first name, last name, ID. So your schema should have 5 columns, right? Then only it will work. I mean the original table. So this table called user3 will hold your original data. So what you will do, first you will load the data here. How do you load? Load data in path, because already it is in Hadoop. Where is in Hadoop? Raghu / what's the file name? User info 3.txt, right? Is that the name? Into table user 3. Yeah. So do till this, load the data to user 3 table. Yeah, so this user 3 table will hold your original data, no partitioning, nothing. Will just have your data. From there I will insert to the partition table. I cannot directly upload the data to partition table in dynamic partitioning. So I should copy the data to one original table. From there I have to insert. In static you are mentioning which country, which state and all manually. So you can upload the data, say create a folder like and then dump the file as it is. Here the file has to be divided based on column values dynamically. Hive has to decide. So you have to load the data to one table. From there you say insert to the partition table and Hive will dynamically partition it. Based on these 2 columns, country and region. Here I have created, right, country and region. Yes, first all the countries, within country regions. So right now we have around 20-25 lines of data. Only that much will be there. Partition columns should be outside the schema when you define a partition table. So these are the partition columns. Whether they exist in the data or not exist in the data, they have to be outside the schema. You say partition by, there you mention the schema. So it will not be here, it will be here. No, it's not required, only here. Because the total schema will be including the partition columns. So it will understand. Okay, now I want you to do one thing. If you look at the Word file, right? You see these things, can you see this? Right? So these are the properties you need to enable for dynamic partitioning. So the first one is very easy. If you read, you will understand. You are saying that, hey Hive, enable dynamic partitioning. Set Hive exec dynamic partition true, which means by default it is false. By default dynamic partitions are not supported. So you are saying that yes, I want dynamic partitions. But what about this? Let me copy that. So even if you enable dynamic partitioning, by default in Hive what happens? If you create a partition table, at least one static partition should be there. So it's a bit complicated to understand. So there are a lot of layers of security, but everything you can override also. So in Hive, first they say, I will not allow you to create dynamic partition at all. Only static is allowed. So you say set Hive exec dynamic partition true, which means now I can create dynamic partition. But then they are thinking, if you are allowing you to create dynamic partition, what if again you try creating 1000 partition, 10,000 partition? So there is a strict mode. Now we are in non-strict. What will the strict mode tell you is that even if you are in dynamic partitioning, okay, you have to first create one static partition in the table Rest can be done. One column you static you do, rest everything has to be dynamic. You can again turn it off. So many people have a confusion. Each partition table. So right now our partition is based on what? Country, what is that? Country and region, right? So what they are saying, country you manually mention while uploading, country partition you manually mention, region Hive will decide in strict mode. It will not add, it will manage internally, but it is saying that manually you mention at least one static partition need to be created. It is just a safety measure. Even in production setups we disable it, because who want to do it? You have 3 columns and one column you have to statically mention, means nobody is able to allow you to do that, right? But sometimes it is very useful, I'll tell you, because you are getting the data where there is no country column. Okay, so you want to add a country partition, that will be static. You have some other data, let's say I don't know, state or something, that already is there, so that can be dynamic. So in that case you don't have to turn it off, because you will mention country statically, there is no other way. Rest of them it will be dynamically creating it. So we are turning it off because it's a developer environment. It's fine, we will create as many partitions as we want. Normally these are all true. I mean like dynamic partition is false, which means you cannot create any dynamic partition. This will be strict by default. So what we do is that yesterday somebody asked me, even I forgot to discuss it, you can create scripts, Hive script like SQL script. You create SQL script, right? .SQL file. Same way I can copy all these commands in a text file, save it as .HQL. I say run, it will run as a script. That's, you won't type everything, right? Who does that? So in the script while doing, you will first add these things, you know, set this and just run it. That's how usually we do it. It can be SQL also. SQL or SQL, only 2. Technically I have not tried anything apart from that. Normally we try either SQL or HQL. I don't think if you add any other, will it work if you have a SQL script? It will work. Hive I have not tried, because all the scripts we have is HQL. By default people save as HQL only. I have not tried. It might work. But I am saying, so, and these are specific to your session. So Hive's language is called HQL, Hive query language. Okay, and this is not a script. We are not writing scripts. This is the shell. This is the query. Script is different. What I am saying, all these commands you can write in a text file, notepad, and you can say run the notepad. It will execute one by one. You don't have to copy paste each time. HQL, it is Hive query language. So
Hive is mainly for converting SQL queries to
so that's what I said yesterday. The language of Hive is called HQL, which is derived from SQL. So 95% is similar. There are some very rare commands which only Hive has, SQL doesn't have. So I think it is SQL 2002 dialect what it is using. SQL 2002. There are ANSI formats, right, for SQL, SQL 92, SQL 2002, SQL 2004. Hive is built on SQL 2002 if I remember. SQL format I am saying. This is syntax, right? Do you find any syntax different from your regular SQL syntax? Partitioning clause is different, right? That's what I am saying. So if you are doing partitioning in SQL, it's not this command. Slight difference is there. So these two properties I think you understood. What is the enabling dynamic partitioning, and the mode is non-strict. Now again for controlling, this is Hive exec maximum dynamic partition 100, which means you are restricting maximum number of dynamic partition is 100. Then this property is not actually correct. The property is correct, but you should find a different value. For example, let's write it as 100. What this means is that, so when, let's say you are creating dynamic partitioning, let's say you have a very large file, and let's say in the column you have 150 values, countries imagine. So 150 partitions will be created. Each partition will be created by one reducer. It's MapReduce job end of the day. So this creation of partitioning table will fire a MapReduce job end of the day. So one reducer will work to create one partition. So if you have 150 partitions, 150 reducers will work. Here you can control it. This dynamic partition per node 100 means maximum number of reducers will be 100 used. So if you want, you can control the number of reducers. Okay. The advantage and disadvantage is different, meaning sometimes what is going to happen, you may not really need 150 reducers to do the job. Correct. So if you have 150 partitions, if your data is very less, you can achieve it using 50 reducers maybe. So you say limit it to 50, only 50 reducers will be launched. So this you are saying, so these values are wrong. I am saying wrong in the sense you are saying maximum number of partition is 100, that's fine. Okay, maximum reducers are 100. So ideally here 100 reducers will run if you have 100 partition, but mappers will depend on your input split, right? Again, so like what data you are getting, so that you don't have any control anyway. Reducers only you have control. My point is, if you are having a very small file, okay, and probably 100 partitions are there, you don't need 100 reducers, probably 10 reducers can do the job. So you can control this property. And I didn't make up these properties, it's available in Hive. Okay, so people will be thinking that, okay, from where did you get all these properties? It's properly documented. I'll give you the document for this. You can copy any of these properties, go to Google, just paste it, and Hive language manual will come. Not the first one, okay. So this is Hortonworks. I mean the original Hive language manual will come. If you open this, just search for here you have all the properties. Where is it? Hive exec dynamic partition, default value false. Okay, whether or not to allow dynamic partition. Hive exec dynamic partition mode, default value strict. In strict mode, the user must specify at least one static partition, right? Hive exec maximum dynamic partition, default value 1000. Hive exec maximum dynamic partition per node, maximum number of to create an each mapper reducer node. That means how many reducers will be used total, right? And you also have other properties for Hive. We will look into that later anyway. So if you come here, so we have enabled all these features, right? And now what you should do is that, where is the Word file? Here. You have to simply say insert. So this command, you will say insert the data from the table to the partition table. This is how you do it. And this will fire a MapReduce job, you can see. And you can see on the screen, it will create partitions. Look at my screen, or you can look at your screen also, whichever. You can see the partitions loading, loading, loading. I'll show you. Because dynamic, right? So see, country null, region null right now. See? Can you see? Country Nigeria, region, Pomoski, whatever, Oman. See, all these partitions are loaded dynamically. And verify that in Hadoop. Verify whether this is created in Hadoop, right? If you go here, what is the table name? So if I go to user 2, see how Korea came. I think it didn't come. It says just Korea, North Korea we had, right, in quotes and all. Yeah, I disabled. We are in non-strict mode. And any country you take, there will be a region. Any region you take, there will be a part file. Because it is output of a reducer. That is why that 00 comes. Reducers will run. Right? I think I don't know how many reducers ran for this. That's another thing. So this is 0, right? And if I go to something else, yeah. So that means those many reducers ran, right? Because everything is 0. So otherwise 0, 1, 2, if it is same, I'll just check. We can actually see the statistics here. If you go to not workflow, job browser, there is a job browser and this is the job we ran. Did I show you this? No, I think I showed you first class. If I go here, there is a task. It's not displaying everything. It's showing stage 1. I'll see anyway. So are you able to run this? I said yes. I think yes, right? Can you see the partitions? I don't know how many reducers were called. We'll see that later. But are you able to create this? Just look at your HDFS and see whether you can find all the partitions. Yeah. Because of the input data, right? So our data need to be either changed. I think because all other data is like regular. So here if you give like this, or you have to clean this. I mean, so usually what we do is that, I mean, if there are only limited records, you can use either pig or spark to clean the data. You can easily clean it. You can say that find quotes and then replace. So first column name that you give in the partition will be the top level partition. Within that it will create those many sub partitions actually. But rest of the partitions are loading, right? There is no problem, I think. How do you search? So there is no way to search for rejections from here. You have to manually verify, because here it says country equal to Korea, region equal to North. That's all. It didn't reject it actually. It created Korea, then the region is North actually. That is incorrect. Okay, as per. So before loading you have to validate the data. That is only way. So we do that. There are validators which can do field validation and whether all the fields are like this, and exception handling. This you have to do before you do it. This data set has an exception, that's fine, but usually you have to validate. Now, so this is usually how you do dynamic partitioning. And one more thing is that when you are doing dynamic partitioning, there are performance problems sometimes, like creating too many dynamic partitions is not advised. Even Hadoop will not allow, because name node has to handle all the metadata for the subfolders and the files. Like you are having 150 countries and each country has states. So if you say divide by country and state, thousands of folders will be created. So that will increase the metadata on name node. So in one way it is good, your queries will be faster, but other way, so there is no limit as to how many you can create partitions, but we say that do it with caution. No, only thing is that your name node performance will be affected, right? Like thousands of partitions are not a big problem, but so many huge number of partitions are there, that will become a problem actually. It's not table size, so usually when you use partitioning is that if your queries are running slow, like, and the reason is that inside the same folder you are having multiple files and it has to scan all the files. And there are some cases where you cannot do partitioning. You may not be able to find out a logic to do partitioning. Probably there is no common column or something. Then I can't do partitioning. There is no other way. It's not like everybody must do partitioning. There is no rule like that, right? Now somebody asked a question, right? So this will lead us to bucketing. But what if I am having, let's say you are getting data from the country side. So you decided to partition. So it becomes country, your partition column, and there are 150 countries. Look at Amazon, look at Dell for example. Dell has presence in 150 countries, okay, and so customers are buying products of Dell and they have some data which is country wise, okay. So what they decided to partition based on country. Fine, no problem. Now after this, what happened is that, so every time when customer is purchasing a product, there is a transaction ID, right? and they want to write queries like this. Select something, okay, where country equal to India, okay, comma, transaction ID equal to 1234. Now the problem is it's already partitioned based on the country, so that part is saved because it will look at only India, but within India you have millions of transactions. So this transaction file will be huge, it has to scan all, probably there are multiple transaction files, okay, and you cannot partition based on transaction ID because every transaction is unique, right? So what do you do? That's the question. And I don't know whether this is available in RDBMS and all. We do something called bucketing. You have something called hash partitioning, right? Can you tell me what is hash partitioning? In RDBMS I am asking. RDBMS you have, who knows about hash partitioning? What is hash partitioning? Because this bucketing is very similar to hash partitioning in RDBMS side. I have not done hash partitioning. So what we do is that, see, there is a transaction ID column, right? This is your transaction ID column. And here what are the values you can have? Let's say 1, 2, 3, 4, right? Like this transaction ID. And let's say 1 million. This is the data you have. Now you want to divide this data based on transaction ID and you cannot do partitioning. You say bucket it. When you do bucketing, it can be done only on one column. You cannot say 2 column bucketing, not possible. And I say I want to create, let's say 10 buckets. So you always mention the number of buckets you want. That is all you do. What is going to happen? Within each country partition, it will create 10 files, not folders. It will divide this data based on an internal hashing logic, okay, and create 10 buckets, 10 files within each country folder. So when this query hits, it will calculate the hash of this, okay, and find out which file is having, it will hit only there. So to easily understand, this is not the actual idea, but 5, 6, 7, 8, 9, 10, 11, 12. These are the transaction IDs. Now I want to divide them into 10 files. So there is an internal logic which Hive uses. I am not going to tell the same logic, but when I say I want 10 buckets, 10 files will be created. Fine. So I say 1, 2, 3, 4, 5. These are the files, okay. And let's say we take a very simple logic. You want to find the modulo 10. You know modulo 10, right? What is the modulo 10 of 1? 1. So this will go to this bucket. This will also go where? Are you able to understand? This will go here. This will go here. Well, it is not doing like this. I am saying similar. So there is an internal hashing logic. And then when you write this query, it will look at 4. It will go to 4th bucket. That's the logic. Not this logic. It doesn't do modulo 10. Okay, it does some other complicated logic, but it will internally divide. We don't have to bother, it will internally divide. Now, many people have a misconception that you should always use partitioning and bucketing together. No. I mean, it's a misconception. People who are already working, I have seen a lot of people discussing, no. But in most of the examples, when you search, you want to learn partitioning, people will say that I will first create partition, then inside that bucketing. That's a practice, but you can independently create bucketing without partitioning. I can simply take a table, say I want to bucket it. That's all. I don't want any partitioning or anything. So what will happen? In the same folder, it will create those many files, 10 files. Physical files. We can see that. Bucketing we can see. Practically we can see. If you can do partitioning, don't do bucketing because that's the most obvious thing. Where you cannot do partitioning, you enable bucketing. For example, India is there. Within that, you don't have any choice. And there is no ideal way to decide how many buckets are required. I mean, so next question is how many buckets? 10, 100. So ideally you should take care that the file size should be somewhere near to the block size. Don't create like 1 MB size bucket. So if you are having, let's say the data is 10 GB within a partition, okay, you say create 1000 buckets, you know, it will become very, very small. Don't do that because that will create smaller files. So ideally take a block size calculation. How many buckets you need, you have to decide. Some logic you have to use for that actually. If data becomes big, that's not a problem. Data should not become small, that's a problem. Like bucket size should not be 1 MB. Then it will create too many small files in Hadoop, right? Hadoop doesn't like it. So if the bucket size is 500 MB, fine. It can become 1 GB, it will still divide into blocks. That's fine. We are okay with it. Not the block size. I am saying bigger than the block size. If it is smaller than the block size, Hadoop always doesn't prefer that because smaller files are not very well handled in Hadoop. Okay. Join operations. These buckets are excellent for join operations. There is something called bucket join. So Hive has lot of advanced concepts. For the time being, you may not be aware of that. Okay. So what will happen is that I have a table here. Okay. And this is my column and this is bucketed. So this means this is divided into let's say 5 files. 1, 2, 3, 4, 5. I have another table that also has the same column that is also bucketed. Possible, right? And this is also having either same number of buckets or multiple. Then you can do a real fast bucket join. There is something called bucket join. Because since the data is divided into equal partitions, the joins will be really fast actually when you bucket it. So when you write a join query, you will say use bucketed join. There is a command you can use. I mean there can be mismatch. When you do join operations, there should be a common column, join column, and usually they will have similar entries, right? That is the idea you are doing join. Otherwise, what is the use of a join? So this is like you are having 2 tables and you want to do a join operation. Normally you can do a join, no doubt, but if the join column, common column is bucketed, okay, then there is something called bucket join you can use, which will be faster. Hive will internally make it faster. Since it is bucketed, the join operation will become faster, hashing. So, and there is multiple types of bucket joins actually in Hive. So it's very interesting. It's a bit advanced concept, but these things are possible in Hive. No, that's anyway just an, so it's very rare that you may get a chance on this, but people are aware of these things like bucket joins you can do, right? So we can do bucketing practically. That will be better, right? Rather than talking. So why don't you look at another data set? So can you open this bucketing data? How do you open with what? Excel, right? See, this is a very interesting case study because here you can appreciate more partitioning because we have similar things. See, you are having street, right? And the street is having almost unique values, some unique at least. City is Sacramento, zip code you have, state you have California, bedroom, bathroom, square feet. So this is this thing, real estate data, and type is residential, condo, blah blah blah, price, some price, right? So, and how many lines of data you have? 986 lines of data you have. Now our intention is to do bucketing, but we will do partitioning also, just to see. Anyway, we can do that. So what I want you to do is first upload this data to how do you upload? The file name is real_state.csv. That's the file name. Okay. And I want you to open this WordPad, which will be here, bucketing Hive. Yeah, so what we are going to do, first we will create a table, okay, and this is a normal table, okay. I'll say create table RE state, that's called real estate, and this has the schema, regular schema, no partitioning, no bucketing, terminated by comma, regular stuff, no changes. And we will load the data. How do you load the data? Load data in path. So I guess you will be able to load the data. So this, if you create, what you can do is load the data, and you have to enable bucketing. So again, bucketing is disabled. So just say set Hive enforce bucketing true. So the command hive.enforce.bucketing equal to true will enable bucketing, right? And look at this command. This is probably the most important command. Create table. You are calling the table bucket underscore table, and I have the schema partition by city, clustered by street into 4 buckets. What do you mean by this? Partition by city. So city, you have common entries, right? I think Sacramento or something. So I'll say that partition column is city. Then I'll say clustered by street. So street column into 4 buckets. So it will create those many city partitions. Each partition will have 4 this thing, what do you call it, buckets. But it is not mandatory. Another thing is that if a city has only 1 line of data, only 1 bucket will be there. If it has more data, then only the 4 buckets will make sense. Some of the cities will have only 1 street, let's say, it will create only 1 bucket in that case. And now just load it and see whether you can see the buckets. I want you to try. Disabled, yeah, even bucketing is disabled. And now I want all of you to try yourself. I'm just doing an insert. Once the insert is complete, go back to your user Hive warehouse folder. You should be able to find partitions and buckets. So I will even show you my buckets. I mean, like, we just want to see the buckets. So if I go to user Hive, Hive warehouse, mine is May 19 dB. May 19 dB. What is the table we have? Bucket table. If I open bucket table, these are the city. If I open a city, there are 4 buckets. But again, bucketing also depends on distribution of data. See here, the last 2 buckets are not having any data. But if you are having only 1 line or just 2 lines, like, then only 1 or 2 buckets will be created. Hive is very intelligent, like very less data, it won't create 4 buckets. Here I think you are having more, like some 4-10 lines. I don't know how many you have. Based on that, it will create. But the last 2 buckets are empty in this example. So ideally you should have more data. This is happening because we are having very less data, right? Some 1000 lines we have actually. But number of mappers will be there, right? Yeah. Either mapper or reducer. I said reducer, so I'll show you here. In that property it will be visible. It can be either a mapper or a reducer. Now when we created the partition, he is saying I am not able to see any reducer jobs, only mapper jobs ran. So see here, maximum number of dynamic partitions allowed to be created in each mapper/reducer node. So it can be a mapper job or a reducer job. If you are having less amount of data, it will be a mapper only will run. But sometimes what happens, you will have huge amount of data and the mappers will first move the data, then the reducers will aggregate into different buckets or partitions. Now he is saying he is not able to see reducers in the job. I am saying it can be either mapper or reducer in the when firing a partition query. It depends on resource allocation. If the cluster is having resources, it will allocate. I got only one mapper. Mine is actually only one mapper, no reducer at all. Yeah, it can be either a mapper or reducer. It doesn't matter actually, to be honest. What is going to happen is, when you created that partition table, right? When you do an insert, what is happening? MapReduce job. So, and what is that MapReduce job doing? That is my question. It has to segregate the data. That is what it is doing, right? It is not doing any other logic. It is just segregating the data based on your partition or bucket, you know. So right now you did, so did you check this partitioning with bucketing? Is it also not firing any reducer? You are saying that the recent one, right? With bucketing. So you are getting reducer? 0. Mapper is there. How many? 1 mapper. Yeah, even I got 1 mapper. So sometimes what happens, if the cluster has enough resources, it will fire mappers and reducers so that it can complete really fast. So mappers will first probably segregate based on partition and reducer will just calculate the hash and dump it. But if the cluster is not having enough resources, this job will be very slow. Only mappers will be launched. They have to complete the whole thing. But there is no intelligence in it, I am saying. It is just a way of the cluster managing your partitioning process. The logic is written, but you cannot really say that it has to be done by a reducer or a mapper. Right. Sometimes it will be achieved only using a mapper. Sometimes it will shuffle and fire a reducer also. Yes. In my case it was done. There was only 1 mapper in my MapReduce job. In his case I think 4 reducers were launched. So probably there was some shuffle operation. Depends on where is your data also. Another thing is that when there is a reducer, there is shuffling of data. Data shuffles and then goes to a reducer. So I don't know, probably in his case some shuffle operation happened. That is why the reducer kicked in. Anyway, it is not really important, I am saying. I mean, while inserting into a partition table, it really doesn't matter whether a mapper is doing it or a reducer is doing it. It does not have any impact on the developer side because it is just a finding by column and then moving the data. That is all you are doing. But in a query and all, it is very important because if you write a proper query, how many mappers, reducers get involved, that's very important actually. Hive can also store the result as text file. So let's say you write a query and the output is normally shown on the screen. Like you write a query, it will show there. You can say save it on HDFS, the output, whatever query output. The command is insert overwrite directory. There is a command called insert overwrite directory. Then you write your query. What will happen is that whatever is the output of the query, it will save as a text file on Hadoop if you want to save it, right? So normally you want to see, but sometimes you want to save. If you want, you can do that also directly. It is insert overwrite directory, if I remember, because we rarely save it as text file. Okay, Hive insert overwrite directory. So this is the one, insert override directory. But I have to see. It is there. You can try this command, insert override directory, and then you give a path and then you say select star. So let's try that. I will say directory. What we will say? Where is the spelling? Oh, direct. Insert override directory. I will say Raghu/ABC count star. Give me a table name that we created just now. NASA log, right? There is a NASA log, right? So this means it will create a folder in Hadoop in Raghu ABC. There the result will be stored. Query result. If you want to store it somewhere, you can do that. You can try this out. See, so when you are creating a Hive table, it store it as a text file. By default, whatever data you are loading into a Hive table, it is available in Hadoop, and that will be in a text format like CSV or any text format. And over the period of years, there has been lot of compression techniques to compress the data. So while creating a table, you can mention how to store the data. Now I have some very good Hortonworks links. I will share it with you. Is there a way? Okay, I can. Anyway, you are not going to see, right? I'll just open my mail because I just shared some links I wanted to show you. I think in your assignment this is there, ORC, right? Correct. And that is very easy. I mean, so storing the data as ORC is very easy. You just need to understand what is happening. Yeah, very rare customers are there in Hotmail, right? I never quit Hotmail. Yeah, so here is it. So there are some Hortonworks links which I found very interesting. Okay. So ORC is a format. So this is a Hortonworks link, but so ORC files in HDP, better compression, better performance. So when creating a Hive table, last line you can add store as ORC. Only one thing you need to do, just say store as ORC. And what is going to happen, whatever data you are loading into that table, Hive will compress it. ORC stands for optimized row column format. It's a compression technique. What is the advantage? First advantage, your data is compressed. Well, that's not a great advantage maybe. Second advantage and the most important advantage is that ORC has indexing. There is a technique called indexing, right? Now in Hive, you by default has indexing, but that is very poor. If you enable indexing, you will not get any performance. What ORC does, it will compress your data, and whatever data is in the compressed file, it will create an index inside that. So when you hit queries, columnar queries and all, your queries will be really fast if the table is having ORC property. Column indexing, regular column indexing you have, right, in RDBMS and all. What is indexing? In order to faster the queries, you will create sort of like a, how do I say, pointer to the original data. ORC will create an index on row and column as well. There is row indexing and column indexing. It will create on everything actually, and it is very efficient. Apart from ORC, if you want, you can create normal indexing in Hive. There is something called bitmap index and compact index, but they are very inefficient actually, because even if you create an index in Hive, you are not actually dealing with name node or HDFS. You don't know where is the data. But if in ORC what is happening is that you are asking Hive to manage the data, compressed data, so it will create its own index for the whole data and store it. Now I'll share this link, but if you scroll down, one of the things that they say here is this. So these are, so if you have a 585 GB file in Hive, if you store it as text file, this is the size. There is a format called RC file, it will become 505. There is another format called Parquet, it will become 221. If it is ORC, it is 131 GB. That is the level of compression you are getting. So Parquet and RC are other compression formats. RC is not very common now, because ORC is optimization on RC. RC is row columnar, ORC is optimized row columnar. So RC nobody is using. Parquet some people use. So Parquet is also another compression technique, but Parquet does not have indexing or anything. It will simply compress your data. That's all. ORC has this advantage of indexing within that, right? So that's one advantage. Avro is a serialization format. How do I say? So let's say you are sending a lot of data. You can send the data along with the schema. Normally, where will you mention the schema in a table? Now, Avro is a format which can apply schema even to text files without a table or anything. While sending the data, you can have a header on schema. So it is very common in Hadoop systems that you use Avro format. Okay, and if you scroll down, so this is how ORC will store the data. This is one thing you need to understand. So it will create index on, let's say, first 10,000 rows. You can mention how many rows you need to create index. It is a row and column index. So here I am saying that 10,000 rows I want index. So what it will do, first 10,000 rows it will create an index and store here. Next 10,000 rows it will create an index and store here. So if somebody is querying, it can understand which group of rows it has to push, and it can even skip these 10,000 rows in one shot. Let's say you are writing a filter condition. Since it knows what is inside here, it can simply skip this entire 10,000 row and scan here. So it's very fast if you do it in ORC. Other formats do not have this ability. And there is something called vectorization in Hive. It's an advanced property. Vectorization will allow you to read thousands of rows in one shot. Normally when you are reading the data, it reads one row, second row, third row. If you enable vectorization with ORC, ORC can read thousands of rows in one shot. So vectorization and all will work only on ORC. ORC is the only format which supports vectorization. Also this batch indexing, these properties are only available. And when you go to Hortonworks, I told you that you can have ACID properties in Hive. You can enable real-time queries. The condition is that the table should be ORC, then only ACID will work. So for all these reasons, people prefer ORC wherever possible. But what can be one drawback? These are all advantages, but what can be one drawback? Exactly, it has to decompress. Meaning your CPU cycles might be required. Anything which is compressed, you have to decompress. So compression is okay, you are storing it, and that's okay. But when you are querying, it has to uncompress the data, right? So CPU cycles are required, but still people are preferring it because they are okay to spend some money on CPUs, but still it is very faster and gives you all these properties. So just go through this link. One link is this, okay, and stride is this. This is one stride. This 10,000 rows is called one stride. That one block of rows is called one stride actually, okay. And this is the speed of queries of 1 terabyte data. So this is Hive 1.0, this is Hive 1.1, that's fine. And then Hive plus vectorized query, Hive plus PPD. PPD is predicate push down. You know what is predicate push down? Like sending your filter first, right? So if you write a query like this, so let's say you are saying that join the data and then filter the data. This is bad, right? You are saying join the data, then filter the data. First you should filter the data, then join. So by default in RDBMS and all, it will first bring the filter together. It will optimize. In Hive you have to manually do this. That is called PPD, predicate push down. So if you enable PPD along with ORC, this filter will come first, then join will come. So it will push the predicate basically. That's the idea. ORC, yeah. So and I can show you this. I mean, I'm not just blabbering. If you look at your Cloudera, this thing, Cloudera manager, right? So where is the Cloud Lab? You look at the Cloudera manager, you can see whether these properties are enabled. Probably not all of them are enabled. That's one thing. Let's check. I'll go here. I'll go to Hive and I will go to configuration, and I don't know if I say PPD. No, it is not showing. Enable vectorization optimization. Okay, it is enabled. So this vectorization is the property by which if you are storing the data as ORC, it can read thousands of rows in one shot. If you enable vectorization, it can read thousands of rows in one go and then give it to you. So it makes, so vectorization is enabled. PPD I have not seen. I don't know whether it is enabled or something. If I search for PPD, it is not. Predicate push down, I don't see anything. Predicate, no, it is not there. Probably that property itself might not be here. It is not available. No, ultimately when you are reading, it will not get bulk, it will get row by row. That is a default nature. It is very slow actually. In Hive, when you are reading the data, it's in the row format, right? So when you are creating the table, you are saying row format delimited, and let's say your query result requires, let's say output is 10,000 rows. It will not push 10,000 rows. It will say row 1, row 2, row 3, like that it will come. So it's actually very slow in original Hive. If you enable vectorization, it can read minimum 1000 is there in vectorization, minimum 1000 rows. You can mention whatever you want. Those many will come in one shot. So it's very fast actually while getting the result. And vectorization requires ORC. No other format will work with vectorization. There is a reader for vectorization which is available in ORC only. As of now, I don't think any other format supports vectorization, right? So now the question is that how do you enable this ORC, right? Optimized row column format. So these things are very, very important. Okay, let me see if I can show you from another one. So these are some of the things which you can go through. So when you create a table, all you need to do is that you say stored as ORC. Last line you add stored as ORC and it will become ORC, and it will take the default values. You can even disable compression. Some people do it. So what if you don't have enough CPU power? You want to use indexing and all, but I don't want to compress the data. You can say compression none. It will not compress the data. Possible. And so these are the properties you can mention. In ORC, you can mention the compression. The default algorithm is called zlib. It's very efficient. You can either say none, zlib or snappy. These are the three options. So zlib and snappy are compression algorithms. If you say none, ORC table will be created, no compression. And then you have ORC compression size, number of bytes in each compression chunk. So the more you put, the more compression will happen. In this case it is 256 KB by default. ORC stripe size, number of bytes in each stripe, 256 MB. So each, I told you, right, 10,000 rows like that. So the size of that is 256 MB. You can say that in my table, probably your table has 1 TB data, divide that into 256 like that. And row index stripe 10,000. For every 10,000 row, an index will be created. So this you can increase or decrease. Compression size is the number of bytes in each compression chunk. So that means when it is compressing, it creates something called chunks inside. So what should be the size of each chunk? Minimum size actually. So here by default it is 256 KB. Depends on the data as well. So we leave these things to default. We don't change the compression size and all, because the algorithm zlib or snappy or none you can change, and the stripe size is how it is dividing the data. Like here the stripe size is 256 MB. 256 MB will be the size of your one stripe, right? And in each stripe it will get 10,000 rows and create an index. So probably in one stripe it will create like 5 or 6 indexes depending on how many rows you are having. One, you are mentioning the size, and within that how many rows one index need to be created. It's okay. So sometimes I mean these are the properties, just read, you will understand anyway. Okay. And you don't have to mention this also. So normally when you create ORC table, you just say stored as ORC, because that is better. ORC will take care of the compression itself. These are the values you can adjust if you want to tune them. If you simply say store as ORC, that's also fine. Yes. So if you say compression none, it will not compress the data. It will index it. It will definitely index it. But no compression will be there. No, the default is text file, because for so long people are using text file. I don't know. ORC is an evolving standard. Okay. And ORC has different versions and all. With every Hive release, they will release a new standard for ORC and all. Text file is the standard format, and you don't want to force anybody to use a particular standard, right? This is better. So if you want, you can use it. That's the only thing. You can't read an ORC file. You can see that, you cannot read it because it is like compressed, and only Hive can read it. Hive can only create and read it. It will look like a zip file only, but you won't be able to open and see what is inside. Only Hive or ORC readers can read it actually. Like you want to set up a small setup, or like in a production you want to do it? Production. So obviously you need machines, and you may not be setting up only Hadoop and Hive. Because people will be having the complete package actually. When you say Hadoop and Hive, that's only two tools, right? So rather than setting only Hadoop and Hive, so it's very easy. You have to have machines, then you have to go to one of the vendor, either Cloudera or Hortonworks, get their distribution, install it. If you are using Apache Hadoop, you have to first download the original source, extract it. There are 4 files: core site XML, HDFS site XML, yarn site XML, MapReduce site XML. In each of these files, XML files, you have to manually type the properties. Probably take a year to complete almost, and you will not succeed. Even I will not succeed because it's very difficult. Nobody does that. We used to do it. I used to set up Apache clusters, but very complicated it is because everything is manual. There is no automation, everything, and there is no use for that also. Only use is that probably you want open source Apache. That is Hortonworks. The Hortonworks edition and Apache edition are exactly same, no difference at all. Yeah, even Cloudera and Hortonworks, there is a free edition. Okay, so since all these companies are selling open source products, you can go to Hortonworks or Cloudera and download their product, install them on as many machines as you want. The problem is you will not get technical support. In Cloudera, you have an edition called Express Edition. Okay, what is our cluster? Our cluster should be Express Edition, right? You can check it. So this is Cloudera, right? Somewhere it will be there. I don't think maybe I'll be able to see the edition because you don't have access to everything, right? See Cloudera Express. This is free. So we are running on 8 nodes or 10 nodes, right? This cluster. It's absolutely free. You don't have to pay a single penny to Cloudera. But if something happens, they won't help you. Like technical support is not there. The commercial edition is called Cloudera Enterprise. So when you are installing the cluster, it will ask you, do you want Express? Do you want Enterprise? If you say Enterprise, they will ask, please browse and upload your license key. Then only the installation will proceed. Actually, so if you want to test or try something, any of this, there are people who run on hundreds of nodes in this edition, Express edition. No, the Hortonworks sandbox will not run in multiple nodes. It's only single machine setup. That manually you have to install. I'm not quite sure whether it will work because the sandbox is designed for one machine only. It is not designed for distributed. Like it is running only, it cannot be expanded. Even if you connect both of them, they won't work because they are working as independently. Sandbox is a virtual machine which you can download and install on your PC. If you start it, it will have everything, Hadoop, Hive, Spark, everything, just to learn, like a single machine setup. Production setup is totally different, installing and all. So that comes in the admin side. That is why I'm not talking much about it. You may not be able to understand even if I say, because there are a lot of other things apart from just Hadoop or something. You have to set up a lot of repositories, then machines, and mirroring and racking, and then the setup is same. You will have, let's say, 100 machines, one will become master, and in every machine you will use either Cloudera Manager or any tool to download Hadoop and distribute. So then you have to first, what you need to do, you have to download this tool called Cloudera Manager. Download it on one machine. Then start Cloudera Manager. It will ask you how many machines you have. You say 4 machines. It will ask you which one you want master. You say this machine. It will download, install, do everything for you. So Cloudera Manager, you have to install on one machine, and then you start it. It will immediately ask you how many machines you have. You give the IP, it will detect. Then it'll ask which one is your name node, which one is the data node, which one is. So you select this. It will download Hadoop, distribute it, install it, set it up, and give you the cluster. That is how this cluster is created actually. No, there is no limitation. You can have thousands of machines, but people don't do it actually. I mean, if it is a production setup, they go for enterprise licensing. But even the Express edition is pretty stable, and the Express edition does not have some features of the enterprise edition, like you have something called rolling restarts and rolling upgrades. For example, let's say you want to restart a machine in a cluster. Now usually when you restart it, it will have tons of problems because your name node will detect this is down. So sometimes in the Hadoop cluster you might want to restart all the machines. You applied some patches or something. And sometimes you want to upgrade the Hadoop version. You are running 2.6, you want to go to 2.7. Upgrade will happen, but after that every machine should restart. So if I do this in a production cluster, it is very difficult. So in the Express edition, there is no way every machine will go down. In Enterprise edition, you have something called rolling restart, which means one by one it will restart machines without affecting the cluster. End of the day, every machine could have restarted, but your services will not be affected. And you also have mirroring backups, advanced backup mirroring solutions that are all available only in Enterprise. This edition will not have. All the features will be there, like Spark or whatever tools you want, everything will be there. Commissioning, you can commission on the fly. You can add 2 machines, nothing will happen. 2 machines will get added, immediately they become part of your cluster. It's called commissioning. I don't know if I can show you here. I will not be able to add them, but you go to this host menu and there is something called commission state. It is commission 11 now. That means there are 11 machines running. No, I can't add because I don't have any permission, but there will be an option called add a machine here, commission. And so right now it says commissioned 11. So as of now everything is commissioned. I don't have any admin rights. Otherwise we can just say click add, it will add on the fly, no problem.
This brings us to the end of this tutorial on Hive. Now before you guys sign off, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud and digital marketing. So thank you very much for attending this session and have a great learning ahead.